Hello everyone and welcome to the second and last day of the first International Solid Waste Association Young Professional Group online conference titled The Path Towards 2030, the Envisioned Decade of Changes Towards a Circular Economy Era. My name is Navarro Ferronato, and on behalf of the organizing community, it is our great pleasure to welcome you to this conference. Let me introduce myself. I am the co-leader of the Research and Innovation Working Group of the ISWA YPG and postdoctoral research fellow at the University of Insubria in Varese, Italy. I will be chairing today's program. This conference is an annual event organized by the ISWA Young Professional Group, which aims to create an international platform to promote young professionals working in the waste sector all around the world. The current environmental disasters that we are observing worldwide have proven that increasing waste and emission from other sectors have contributed to climate change, and that especially the younger operations and generation will pay the price. It is time for the transition to the circular economy. This year, we will emphasize the path toward 2030, the reference year of the SDGs. We are giving chances to more speakers as possible to be part of this conference organized only by young professionals for young professionals. Finally, we would like to give voice to those who do not have a voice, to marginalized communities, to informal workers, underline the importance of having interdisciplinary support to move towards the circular economy era. For this conference, we have launched a competition and received abstracts from researchers from 18 nationalities. From a very competitive call, we built 4 sessions, and the best 3 presenters will be awarded. Best of luck to all presenters. There will be free scholarship to attend the ISWA Swiss Winter School. We are really grateful to Professor Sahadat Hossein for awarding these prizes. In addition, free individual ISWA membership for 1 year will be awarded. For that, we would like to thank very much Dr. Arne Ragosnik, Managing Director of ECO Consultants, from sponsoring this membership. I would like to remind you that the conference is divided in 2 blocks to cover all time zones with a comprehensive program. Yesterday, we had the first, coordinated by my colleague Dr. Amani Malouf from the UK, while today we are going to have the second one, with 2 main sessions and 1 special session. We are proud to host a diverse program with more than 25 young talents from 16 countries, from different backgrounds, research topics, cultures, nationalities, and gender. We are grateful to introduce this conference for more than 300 attendees from all over the globe. To all the attendees, please use the chat on the right of your screen to introduce yourself. Comments and questions to the speakers are really welcome. You can submit them by typing into the questions interface. Make sure to introduce yourself and to identify to whom you are addressing them. I wish you all an excellent conference. So let's start with the 3 great invited speakers: Roland Thompson from Spain, Vice Chair of the ISWA YPG, Mr. Carlos Silva Filho from Brazil, President of the International Solid Waste Association, and Professor Sahadat Hossein from the United States of America, Director of the Solid Waste Institute for Sustainability. Therefore, to start this inspirational event, I am pleased to invite Roland Thompson, the Vice Chair of the ISWA YPG, to provide some highlights of the Young Professional Group before we proceed to the conference sessions. Welcome, Roland. Please, welcome on stage.
Hi, Navarro. Thank you so much. So,
Hi, Roland.
Yes. Thank you. It's a great pleasure to have everybody here today. And first and foremost, a huge congratulations to Navarro and Amani for organizing this event. Yesterday was thoroughly enjoyable, and congrats to yesterday's speaker, and I'm so excited to see what's going to happen today. So let's just give you a little bit of context to where we come from and why we exist. As you might know, we are part of the International Solid Waste Association, whose goal and mandate is to promote and develop sustainable and professional waste management worldwide, as well as the transition to a circular economy. ISWA is made up of a core group of employees, many members from around the world, including private sector, public sector, government organizations, and individual members just like me. We also have plenty of working groups, and the Young Professionals Group is one of them, and some really high-profile partners, like you can see on the slide, like the UN Environment, the WHO, and Wiley, because of course we do plenty of excellent work in the research space. Going on a little bit to the YPG, the group organizing today's event. We have 150 people, all under the age of 35, from many, many countries all around the world. And our main focuses are what you see on your screen. We help young professionals develop their career. We do this with our mentorship program, and we do this with many events, teaching young professionals how best to develop themselves. We also have a communications portfolio, which organizes our social media, our marketing, and our relationship with the YPGs. We, of course, work in education. There, Adeline leads a really active group, creating educational material for schools and for universities. We also have plenty of events happening all the time, so keep up to date. Follow us on the socials. I'll show you where we are now. And we also have a wonderful group of regional networks from every continent of the world. So wherever you're from, I would encourage you to see if we have a regional network there and join it and get involved. Lastly, and most importantly for today, we have our research and innovation working group, headed up by Amani and Navarro, and they do fantastic work, just like you're seeing before you today. So we are very active on Facebook, Instagram, and LinkedIn, and I would ask everyone to check us out there. You can just search for us, ISWA YPG, ISWA Young Professionals Group, and please give us a follow so you can stay up to date with everything that's happening. As you can see in the background, I took a screenshot of one of our recent meetings, and you can see Amani and Navarro in the top left and right corners doing what they do best. So one last thing, each year we do a flagship campaign, and next week we will get down with this a little bit more. And if you follow our socials, you will see what's happening there. But it's a really interesting campaign we've organized this year. It's essentially tackling the concept of information or false information in this post-truth world we find ourselves in. And I would encourage you to all get involved. So thank you so much, and on to the next speaker.
So thank you very much, Roland, for your introduction to the ISWA YPG. So now let's proceed with our second invited speaker, Honorary Chair of the conference. Ladies and gentlemen, I am taking great pleasure in introducing our conference Honorary Chair, Mr. Carlos Silva Filho, who will give us an opening address. Carlo is the ISWA President, a Brazilian lawyer specialized in administrative and economic law, and Executive Director of ABRELPE, Brazilian Association of Waste Management Companies. Therefore, let's welcome our ISWA President, Carlos. Please, the floor is yours.
Thank you, Navarro. Thank you all. It's a great pleasure to be with you here today. Congratulations to all the YPGs for organizing this amazing conference. And I'd like to congratulate Navarro, Amani, Dan, Roland, and all the YPGs team to be together organizing this truly global meeting. I was looking here at the chat, and it's amazing to see people and young professionals from all over the world. We can see our presence in different countries, in different continents, and this is what makes ISWA truly global. Meanwhile, I was listening to Roland. I was remembering when we got together in 2013 in Vienna during the World Congress in Vienna to found the ISWA Young Professionals Group. And I had the honor to be the first chair of this group. And it's amazing to see how far the group has reached, how professional activities have been developed, and the outreach we achieved so far. It's important really to get together. It's important to give voice for those who usually do not have a voice. And it's important to provide content, network, engagement to all of you who are part of our association and who will be not only the future, but who will make the present of our sector, of our industry. And it's important here to highlight the theme of this conference related to the path towards 2030. It's the deadline set by the United Nations, by several other institutions, when we need to achieve some important goals in order to be able to continue living in this planet with some quality of life. It's important thus to highlight ISWA's mission, which is to promote and develop sustainable and professional waste and resources management towards a transition to a circular economy. So here, from the ISWA mission, we can take some very important concepts, some very important definitions, and some very important commitments our association has taken and has been working in order to be able to implement. We all know who work in the waste field, we all know that waste is increasing at a high pace. Current estimates show that the world generates around 2 billion tons of municipal waste annually, and current perspectives show that waste generation will increase 70% by 2050, reaching more than 3 billion tons. And this trend will affect developing countries the most. So it's important for us to draw, to plan, and to implement sustainable and feasible solutions towards this great increase we will see in the coming years. And also not only to deal with these future amounts of waste, but also to revert current deficits, current problems that we see, current problems such as 2 billion people in the world do not have access to basic waste collection, and 3 billion people do not have access to controlled disposal facilities. So we have almost half of our population around the world lacking of this basic human right, basic waste management services. And these numbers indicates that the current situation poses an environmental and a health emergency that require immediate actions to revert and to ensure that sound waste management is really implemented and delivered all over the world. We all know from several ISWA reports that these inadequate waste management systems that are still existing in different parts of the world poses a threat to public health and results in enormous impacts to people's life. So we here needs to go upwards the sound management system. We need to go upwards the waste hierarchy to solve this huge environmental and health problem at local realities in different countries. And here, again, it's important to remember the clock is ticking, and we need to act now before the point of no return. And the deadline set by the different institutions is 2030. So we have less than 10 years to act, to mobilize efforts and resources in order to contribute towards the world we want. It's important to say that a big storm is coming. And I'm not talking about the pandemic, which is already here. I'm talking about the different challenges we need to face and we need to solve in order to advance. I'm talking about climate change. I'm talking about the recession, the economic recession. I'm talking about biodiversity loss. And here we need to be aware that the waste sector can play a unique role towards the benefits in all of these challenges. We have a unique role to play in order to prevent further environmental degradation. If nothing changes, we'll have more wastes, we'll have more greenhouse gases emissions and global warming, we'll have more pollution, and all of these together will become bigger challenges at bigger costs. We need to change the current paradigm of a linear system, of a system in which we have extraction, production, consumption, and disposal on a linear pattern, a paradigm when the consumerism plays an active role, and we need to shift towards a circular one, a renewable one, a collaborative system for which we have our knowledge, our expertise being a centerpiece, being spread and shared throughout the different stakeholders and the different industries. We are here as waste professionals to provide technological disruptions, to support the advancement of technology, comfort, new ways of thinking and delivering current practices. And we have to talk not only to the current generations, but also to the new generations. And this is the main message I want to say and to leave today during this Young Professionals Group annual conference. You are the current and the new generations. You are the ones who are globalized. You are the ones who are online and digital. You are the ones who are multitasks. You are the ones who are disruptive. And this is where we are from ISWA side to support this evolution, to support you into looking for inspiration, into finding new solutions and new answers to the common problems we have from many years now, to support the development of new social behaviors based on a shared economy, on better local ecosystems, to rethink business models, and most importantly, what I see for today's event, to be really into a network, to be into a circle of cooperation, not more based on individual
Sorry, President, we cannot hear you. Your microphone is muted. Please, can you unmute it? Perfect.
Sorry.
Perfect. Now, yes. Perfect.
Something happened with the
Yeah,
button.
of course,
Sorry.
it can happen.
So here, just taking from the last part, what I was saying is that you are the ones who comes to embrace a new economy. You are the ones who the United Nations for today, for these years, World Environment Day called the Generation Restoration, to restore our ecosystems, to restore our better way of living, to restore our connection to nature, our connection to love, well-being, and happiness. So to finalize, what I want to say is there is no coming back. We are at a stage in our era, in our history line, that we need to look into the past to move further steps into the future. And I'm sure that the post-COVID era is green and sustainable. Is an era when we need to go back to the beginning and move from being waste handlers to resource suppliers towards a circular economy and carbon neutrality. So I thank you all very, very much for today's event, for the opportunity of talking to you, and congratulations for the event. Look forward to seeing you all in person soon. It will be my great pleasure to be again together with our young professionals from different parts of the world. And always remember, once a young professional, always a young professional. Here in myself, you have a partner, you have a supporter, and I really look forward to continue moving forward with your support and your engagement. Thank you very much.
Thank you very much, President, Mr. Carlos, for your presentation. And also thank you very much to be part of this event. So we enjoy it very much. So I think that we can take 3 take-home messages from your presentation. The clock is ticking. We are here to find inspirations, and we need cooperation. I think that can be also a message of your presentation of today's conference. Thank you very much for being part of that. And now let's proceed with our third and last invited speaker. And ladies and gentlemen, again, here we come to an introduction to the ISWA Swiss Winter School. And I would like to invite Professor Sahadat Hossein from the United States of America. Professor Sahadat is director of the Solid Waste Institute for Sustainability at the University of Texas at Arlington and coordinator of the Swiss Winter School. Professor Sahadat, thank you very much for sponsoring our conference and to join us today. Please, the floor is yours.
Thank you very much, Navarro. And I would like to say thank you very much to Amani also. Both of you did a wonderful job. And I'm very happy to be here. Can someone share my presentation? Yes. Okay, so, you know, it was very nice to hear from Carlos. And he mentioned some of the things that I want to start with, that waste generation is increasing. We need to know the technology. We need to go from linear economy to circular economy. But one thing that is also a big part that's missing in the waste management is we have technologies. We have people know how it works, but we need to transfer the technology to different countries. And we also need to understand that what works in one country may or may not work in another country. So ISWA Swiss Winter School, if you look at the front here, it summarizes, part of the things that we do. And you can see Paula here, Amani here. Can we go to the next slide? How do I go to the next slide? Okay. Why we are doing Winter School? The mission of Swiss is an organized research center of excellence. And our main mission is developing clean and healthy urban cities. And we are doing it through sustainable waste management. There are many objectives to get to this mission. And one of the main ones that I emphasize again and again is training waste management professionals, and especially training the young waste management professional, helping them with the ideas, why waste management is important, how they can contribute, and how they can develop business related to waste, so that it's not only that they are working on the trash or garbage or waste, they are also trying to help them and help the society at the same time. With that mission, we started the, next slide, please, if someone can move. Yeah, with that mission, we started ISWA Swiss Winter School back in 2016. When we started the first time, we were not sure how it's going to go, but I think, our program was good, people liked it, and ISWA asked me to continue doing it annual basis. What makes our program unique and different from others? Our program, we focus on two specific things. One, both in-class and hands-on training. We do not want to stay only in the classroom. We do not want to be only in the field. We combine whatever you talk about in the class today, we go to the field and try to look at them so that everybody can link whatever you are talking about, how that is implemented or replicated in the field, and how someone from developing country can come here, look how it's done in USA, maybe can take it back to their home countries and implement it. Number two, we need to create leaders, and through this program, we have the networking. Through networking, we have the team building and friendship. Can you go to the next slide? One before, okay. 2020, I want to start with 2020. I want to give a snapshot of what happens. If you look at the left side of the slide, they're in the classroom. Look at that. They are, in a very serious mode. Some of them are using makeup. Some of them are thinking what is going to happen. And you may know James Law, he's almost sleeping. But the moment we get out of the classroom, that's a different person. Tatiana in the classroom, Tatiana outside. It's a completely different game. So that's how the program is designed, that we have to be in the classroom, we have to be out there. Next slide, please. This is again, in the first week, people are a little bit trying to know each other. Second week, everybody is getting into the mold. Everybody is talking to each other, making friends, networking. At the same time, they're also learning. If you look at this on the left side, they're doing the waste characteristic by themselves. Every group, last 5 years came, they have to do it. We're visiting the field. But along the process, everybody is having great fun also. Go to the next slide. 2019, same thing. Andrea and Aditi, all the people came here. We go to the field. We are in the classroom. Along the process, we learn, and we learn about each other, and we learn about trash. Next slide, please. This is very common. We also have a day when everybody is going out and, excursion in the middle of the week. And at the end of the program, we have a cultural program. And if you see the middle photo in the top, that's basically, they are singing in the bus when you are going from one side to another side. I'm not talking about technical part, what we are doing in the winter school. I'm not trying to say what should be learned. One of the things that I'm emphasizing in presentation, that social aspect, getting to know each other, getting to know the people, having a network, and reaching out to the greater community can help us really reach the goal of solving this waste crisis. Go to the next slide, please. Again, 2018. Every photo you will see one thing is common. Everybody is going to the field. Everybody is doing waste characteristics. Also, other than getting waste management professional or trading, everybody is going back. They're coming to the Texas. Everybody is going back as a cowboy or cowgirl from Texas. Next slide, please. 2016. 2017, everything is similar. Go to the last slide, please. Next slide. Here. Now, when you are doing a program, you're trying to, reach out to people. You think you're doing a fantastic job. But what is the feedback from the participant? This year, 2020, Paolo and Siddharth Vele, they gave a feedback. They gave very rousing feedback, and it was very good. We always get feedback from them on the spot. But they went back and wrote to ISWA, and ISWA published this. And I was very happy that that's the way they felt. I never saw in writing how someone felt about winter school. So that was a very good on their part, and it really made me feel good that maybe we're not doing a bad job. I summarized all the feedback that we get from 5 years of winter school. And based on the feedback, the most useful that everybody said is the site visit. Site visit. Because when you are talking in the classroom and we go to the site, we link both of them together. Many of the training program, this linking is missing. And in the site, we are not only linking, we are networking. Everybody is networking with each other, making friends. So that's very important and serious part of our winter school. That's why last year, when due to the COVID, we couldn't do the winter school. Many recommended should we do it online. If you look at most useful, all three is going to be missing if we're doing online. The interaction part is going to be missing. The site visit is going to be missing. And also we got the feedback, about the organization. Everybody said overall organization of the winter school was excellent. It's more than 90%. Whoever commented, more than 90% people commented on it. Everybody said it was excellent. Final thought, in winter school, go back, please. We are not creating waste management professionals. We are creating MAT people. What is MAT? People who are making a difference in the society. And in the last 5 years, whoever went through the winter school, I can see they're really contributing in the society. Look at Amani. Look at, many other participants. They are doing a fantastic job when going back. Next slide, please. This is my final slide. And this emphasizes what Carlos was talking about. If we do not manage the waste right, if we don't do everything right, very soon we'll be in the crisis mode. So before we go to the crisis mode, we wrote a book on it, and hopefully it will be out in the market very soon. Thank you very much for the opportunity. I always love to talk to the young professional. They are the future of waste management. Now you can play the video. Thank you.
Super. It's something great.
Amazing.
It's awesome.
Very amazing.
Fantastic, unbelievable.
Amazing, man. Amazing.
Helpful. Very, very helpful.
Oh, it's marvelous.
Awesome. Fun.
Awesome.
Perfect.
Great.
This is fantastic.
Wonderful. Excellent.
Fantastic.
Of course, great.
It's amazing experience.
It's really useful.
It's a great job.
Very exciting.
It's a very good experience.
Really good.
Really interesting. It's great.
Most interesting.
Awesome. It's a blast.
Swiss. Revolution begins here.
Thank you.
So thank you very much, Professor Sahadat. Very interesting presentation, very interesting winter school. Here again, two keywords: community, make a difference, networking. I think that these are the most important points. So thank you very much to be part of our conference. Thank you very much for the introduction of the ISWA Swiss Winter School. We hope to join you there in the United States of America. So thank you very much.
Thank you.
And I remind the audience that the top 3 presenters will have a scholarship for attending these amazing winter schools. So good luck to all presenters. Now, let's proceed with the first session of the conference. So let's welcome Mrs. Maria Japinen. We can end with this session, and we can also share the new platform in relation to session 3. So Maria is from Finland, is graduate from Lund University in Sweden in environmental management and policy, and she is currently working for the city of Lahti as a waste management developer. In addition, I would like to highlight that it is important to mention that she is the founder of the Finland chapter of the ISWA YPG, so congratulations, and she is the winner of the third ISWA YPG conference. So many congratulations, and thank you to be here to moderating our third session of the conference. So please, Maria, the floor is yours for starting the session number 3.
Thank you so much. Hello, I guess you can all hear very well. That's the most important question.
Very
Fantastic. Yes. Wonderful to see you all or hear you all across the globe. Hello from Finland, actually from the EU's Green Capital of this year. And my name is Maria Jäppinen, and I will be moderating a third session. And we have 5 fantastic presentations coming up, and I'm super, super excited. And after the presentations, we're going to have a short Q&A. So if you have any questions, you can submit the text question by typing them into the questions interface that you can see on the screen. Please mention your name and state to which presenter you would like to forward your question, and it shall be answered, perhaps. If not, it will be typed out from our presenters. But without further ado, let's start with our first presenter. I would like to welcome Andrea Verli, who is from Switzerland and whose paper, and she will be talking about her work, is titled as the participatory and human-centered design approach for the implementation of an eco-workspace. And short intro about Andrea: she is a social and environmental entrepreneur currently working at the Swiss Federal Research Institute on the social impact startup EcoWork, which is a co-working space for informal e-waste dismantlers in India. So Andrea, floor is yours.
Thank you very much. And I'm very happy to be here. Thank you also for the introduction. I will very quickly tell you a bit more about our startup and then deep dive into the participatory design approach that we use to implement this project. So for you to set the context, in India, e-waste is managed mostly by the informal sector. The work is very polluting and unsafe, but what they do with it and the income that they generate, it contributes to the livelihood of many people. To bring change to the informal sector and transform it is very challenging. So we came up with a business solution, which is EcoWork, which is basically co-working spaces for the informal sector. So providing workspaces and storage room on a pay-per-use basis. So what we want to do is to create a work environment that is healthy, efficient, modern, and support the businesses through different services, and through that create this transformation that is very much needed, and have the informal sector being included in the value chain. Now, before we implement such an EcoWork space, we really wanted to create the concept with the community together. For that, we used a participatory design approach, which I focus on this presentation. We did that in collaboration with an Indian organization called the Community Design Agency. They helped us design the process and implement it. So first of all, one of the key issues is to build trust. Without that, nothing is possible. We created trust through repeated interactions, and always keep in mind, recognize them as equal stakeholders. We also work together with community representatives, and through that, we're able to reach out to a wider community. Then one of the core issues is also to interact with them, to listen to them, to try and understand what it means to be an informal dismantler of e-waste. And here you can see a set of pictures of the interactions that we had. This helps then to understand the network, to understand the linkages and the interdependencies, and finally, to understand what is needed to achieve a transformation. So from that initial interactions, the core results were that it's very important for them to be able to provide for the family. And the network and friendships are super important as well. Challenges that they face were uncertainty as a source of stress and lack of institutional support. They also mentioned that they feel the law is very weak and they felt treated as a source of money rather than people. As a next step, we deep dive into the design of such a facility. And so what we did is we rented an empty industrial space and we brought some of the dismantlers there and gave them some chalk and tape and let them design a facility by themselves. And this was very interesting to see like how much space would they allocate to what and what would they think of, what is important to them. And some of the core results that we got out of that is that it's very important to have secure storage spaces, to have a weighing bridge, and office space and meeting rooms, safety installations such as CCTV cameras were mentioned also as very important elements. Washrooms and resting areas, they kind of are quality of life elements. Surprisingly, a bit for me now, was, for example, that air conditioning was not of importance. Well, and then unfortunately, COVID came, and this really disrupted the whole process. So it ended up in a strict lockdown, in the breakdown of the e-waste market, and no physical interactions were any more possible. So we tried to keep up with digital meetings, but that was really tough, and it was impossible to keep their interest. The good thing was that there was a shift in perception of health issues, and they started to understand the benefits of working in an industrial area. Once it was allowed again, we went back and we showed them a bit of what the work and the progress that we did. And this is an essential part as well. So, because we don't want the people to feel like they're just a source of information. We want them to be part of the project. We want them to be part of designing it together with them. We also spoke with them about the potential location to get their view on that. And then as the next core part was to identify the services that we need to provide. And here we used another approach. We gave them some sets of different services and we let them put them to different posters, which mentioned least important, important, and very important services. And this is kind of an icebreaker to open up. And based on that, we could start more deep discussions on the services. So some of the results that came out of that was that the economics are central to them, so providing services at reasonable costs, and the issue versus the sharing versus owning a facility or workspace was mentioned several times. Now also the logistics and the proximity to existing markets are important. Health and safety is less of a concern to them. Now just to conclude here on a content-wise, what did we do with all this information? So basically we identified 3 big challenges. One is the rental model of a co-working space versus owning a facility. Our mitigation strategy is that we want to have eco-work as a stepping stone and business incubator rather than a long-term stay. The second challenge is the disruption of networks and logistics. So we really need to make sure we got different players to come to work at EcoWork to have the whole chain and network being there. And the third challenge are the economics. So making sure that we pass on scale-related benefits to them. And also what we are thinking of is to create digital market opportunities to them. So open up new economic incentives and make sure that the offers and services that we provide to them are financially feasible to them. So taking a step back and thinking of the overall process that we applied, what I would say are the key lessons learned is that this process through the participation of the informal sector is critical to understand the sector, and it provided key information and insight to help create the business model. What you need to be cautious of is the expectation management. So don't promise too much and don't raise too high expectations, because there are always disruptions happening, being it political riots or COVID, that might delay the project implementation. And also working with the informal sector, it's very, very challenging and difficult to adhere to the project plan. So you need to keep a you need to have flexibility. So with that, if you're interested in it, please do visit our website. There is more information on the project and also on this participatory design process. And least but not last, I really want also to introduce you to the team that's behind EcoWork, and especially to mention here Ibrahim and Shushant, who did a lot of the on-ground work together with the community, and put a lot of energy and effort into this. So with that, I thank you very much for your attention, and should you have any questions or are interested to know more about this approach or the project that we aim to do, or feel like this is something that you could become part as well, do feel free to reach out. And with that, I hand over again to Maria, and thank you again very much.
Thank you so much, Andrea. This is so insightful and interesting projects you are having. Thumbs up. But we have to move on to the next session, and continuing this session, our second presenter coming from Bolivia. It is Jabanel Calle Mendoza, whose presentation title is about analysis of solid recovered fuels, opportunities towards a sustainable waste management. And it's a case study from La Paz, Bolivia. And if I would like to a little bit introduce about it, Iris is an environmental engineer working with Italian NGO COPI on a development cooperative project in La Paz, Bolivia. Iris, your floor is yours.
Thanks, Maria, for the introduction. So hello, everyone. I'm going to present the research analysis of solid recovered fuels, opportunities towards a sustainable waste management. It's the first experience in Bolivia, and it has been carried out in the city of La Paz, thanks La Paz Recycle project. We know the waste-to-energy conversion is a key option for completing the cycle of non-recyclable waste. In Bolivia, the recycle rate reached 40.6% of the total waste generated is used formally and informally, where 0.9% use of organic waste and 3.7% use of recyclable inorganic waste. The picture on the left is the waste classification plant that we have in La Paz City. The current performance is 50% and the other 50% is non-recyclable waste. The final disposal sites, only 3% are sanitary landfills, 6% are controlled dams, and 90% are open dams, of which about 30% are close to water bodies that are used for human consumption. Due to this lack of management in our waste, especially with non-recyclable waste, with this research, we have the following objectives: provide preliminary studies as a baseline for the energy use of waste, and then determine the classification of non-hazardous and non-recyclable urban solid waste as SRF generated in the municipality of La Paz, where we evaluate the most suitable composition of waste to obtain recovered fuels for the cement industry, and determine the calorific value, chlorine, and mercury content for its classification as SRF according to international standard EN 15359, and other parameters such as moisture, ash, and volatile matter. For the classification and specification of SRF can be classified into 5 classes, and we have to analyze 3 parameters: net calorific value as an economical information, class as a technical information, and mercury as an environmental information. If we have a SRF with net calorific value and chlorine values between class 1 and 3, and with mercury values between class 1 and 2, according to the Italian decree DM22, we guarantee the classification of the SRF as a fuel, and it's no longer a waste. The objective of the research is to obtain SRF of high quality in order to be classified as alternative fuel, according to the Italian regulation and the European standards. For this research, we worked at the Cookstop Test Center, CPC. It's a regional reference center funded by the Clean Cookstop Alliance. It has experience to perform an emission and energy efficiency evaluation. And the CPC is part of the Institute of Research and Development of Chemical Process at UMSA. And secondly, the samples obtained for the research were collected from the non-usable waste area of the waste classification plant located in the Alpacoma area. And this air-contaminated waste that can't be recycled. The classification of non-usable waste from the classification plant was carried out to identify the types of waste in each of the two groups, plastic waste and cellulosic waste. We obtained the highest proportion of polypropylene and low-density polyethylene with 64%. About the cellulosic waste, we have the highest percent of recycled cardboard, followed by corrugated cardboard with 67%. So we work with the residues that are in the highest percent for the composition of the SRF. We generate two scenarios. The first scenario, E1, maximizing the use of cellulosic waste, is which we work with different composition of cardboard and plastic, varying the percentage of cardboard from 80%, 40, 30, 20, and 10%. This percentage contained 50% recycled cardboard and 50% corrugated cardboard. And plastic have 50% polypropylene and 50% low-density polyethylene. About the second scenario, E2, maximizing the use of plastic waste, we have three compositions with 20% cardboard with 80% plastic, where we vary the percentage of polypropylene because it's the plastic that we find the most in the classification. We have from 80%, 20%, and 10% polypropylene. The bars inside the green box are the SRF composition with the best classification that we obtained. This slide, you can see many pictures about the different parameters. The laboratory analysis, we work with the European standards for the preparation of laboratory samples, the calorific value, the moisture, ashes, and volatile matter. The chlorine content is determined by washing to the combustion of the sample to be analyzed with multi-parameter equipment with a selective ion electrode to measure the chlorine concentration. About the method applied for the determination of mercury content was provided by the Environmental Protection Agency, EPA. About our results, the moisture content varies significantly with the increase of the plastic content. Similarly, the ash content decreased with the increase of the plastic content, and the volatile matter contents rise with the increased amount of plastic. So we have two SRFs of very good quality that are fuels, and the first with 20% plastic and 80% cardboard that has class 3 in net calorific value with 18.7 megajoules per kilograms. Class 3 in chlorine content with 0.63%, and class 1 in mercury. The second SRF with 80% plastic that has 10% polypropylene has class 1 in net calorific value with 36.5 megajoules per kilogram. Class 2 in chlorine with 0.57%, and class 1 for mercury. About the conclusions, development and usable solid waste analysis capabilities, the Institute at University, UMSA, to be used as refuse derivative fuel, and this can be classified as SRF according to its quality. Then we can see the influence of polypropylene was seen in terms of net calorific value and chlorine content. Also, the results of the research carried out in the laboratory defines a baseline to demonstrate the viability of introducing alternative fuels in the industrial sector, especially in cement plants. We encourage the population to make the separation at origin in order to make better use of our waste as an energy source. Municipal solid waste that isn't recycled can be energetically valued as an alternative fuel, allowing us to comply with SDGs, for example, Goal 12, also under Goal 7. Finally, the findings of the research are of interest to stakeholders in Bolivia and Latin America willing to provide sustainable municipal solid waste management system and alternative energy source towards a circular economy. Thanks for your attention. Here is my email and mobile if you want to communicate with me to know more about this research. Thanks, Maria.
Thank you so much, Iris. This is so interesting. Also, thumbs up and an exciting projects over here. But now I would just shortly remind you, all of you in the audience, and you can submit your questions through the questions panel, which you can find on your right hand, and you can ask the questions in that for the Q&A. But let's move on from South America to African continent. Our third presenter comes from Ivory Coast, and his name is Yeo. Sorry, I can't pronounce correctly. Yeo Donathan, and he's presenting on a mass balance and GHS gas emissions reduction potential of a source-separated biowaste composting plant. And Yeo is a fourth-year PhD student in the solid waste management field at Swiss Center for Scientific Research in Ivory Coast. Yeo, the floor is yours.
Thank you, Maria. Thank you for this very nice introduction. Hello, everybody. Thank you for attending to this session. Today, I'm going to talk to you about the mass balance and the greenhouse gas emission reduction potential of a source-separated biowaste composting plant located in the city of Tiassalé in southern Côte d'Ivoire. Why we conduct this research? Hello, could you understand?
Yes, we can hear you.
Okay.
No problem.
I think I have some problem to move this.
Oh, can you? Yeah.
Okay. Thank you very much. Why we conduct this research? As you may know, solid waste management remains a major concern in sub-Saharan Africa. In these countries, municipal solid waste are characterized by a high water content and a high proportion of organic waste. Hence, composting and especially decentralized composting appeared as one of the most suitable treatment options for these countries. In recent years, despite several initiatives of decentralized composting have been implemented, there is still a lack of data regarding the environmental benefit of these facilities. The present study aims, therefore, at filling this gap by assessing the material flow and the greenhouse gas emission reduction potential of a source-separate biowaste located in the city of Jasali during 1 year. Could you move again for the next? Okay, thank you. So how we did this study? First, let's present the composting plant. The composting plant under this study processing organic waste collected from 220 and 30 households located in the city of Jasali. These households were trained to source separation of bio-waste and provide with waste bin. Then the organic waste were collected 3 times per day, 3 times per week, and transported to the composting plant. This composting plant has a full treatment capacity of 100 tons of organic waste per year. The compost process used is the open windows composting and takes 3 months. At the end of the composting process, the mature compost is sieved into 3 sites. The residues were sent to the municipal landfill, while the 2 other sites compost were sold to the local farmers, please. Next, please. How we did it. First, secondly, the mass flow analysis. The figure 5 presents the system boundary considered for this flow analysis. As it can be seen from this figure, the system includes the composting plant and the municipal landfill. However, waste collection and transportation were excluded as they were assumed to not influence the flow analysis. This flow analysis was performed using STAN 2.6 software. Next, please. Next, please. Okay. 3, input and output characterization. 2 sampling campaigns were performed in order to characterize the organic waste composting. The parameters measured were total solid, volatile solid, pH, nutrient, and heavy metal content. All these parameters were measured using the standard method. 4th, the greenhouse gas emission reduction calculation. The UNFCCC method for clean development project was used for the greenhouse gas emission reduction calculation we studied. For this purpose, 2 waste characterization campaigns were conducted. At each of these campaigns, 6 categories of waste were identified, including food waste, garden waste, paper and cardboard, wood, textile, and inorganic waste. Next, please. What we found, the mass flow analysis showed that the compost production rate was 24%, which is similar to those results found in the international literature. During the composting process, 8.3 cubic meter of water was used for the watering of organic waste, which means that for a composting plant with a treatment capacity of 10 tons of organic waste per day, about 500 cubic meter will be required. Access to this significant amount of water could be problematic in some arid region of sub-Saharan Africa. The composting process generates 110 liters of leachate. The percolation of this leachate into the soil could endanger the groundwater resources. Next, please. The physical-chemical analysis results revealed that the pH and the carbon-nitrogen ratio of the input material was in the range recommended for composting. However, the water content of input material was slightly below the range recommended. So an additional amount of water should be added during the active phase in order to run the composting process efficiently. The compost produced have a very low water content, 12.6%. This low water content have the advantage of reducing the transportation cost. The carbon-nitrogen ratio of the compost produced was below 15, which means that these composts were stable. The nutrient content of these composts were very high, which compared to the result of previous study in sub-Saharan Africa. Regarding the heavy metal content of these composts, the result observed was very low and in line with both French and German compost standards. These low values reflect the low contamination of input material due to the source separation system put in place in this study. Next, please. Regarding the waste characterization compost, the results show that food waste were the most component of the organic waste with 82.5%, followed by garden waste with 5.2%. The figure 9 presents the greenhouse gas emission that these organic waste would produce if they were dumped at the municipal landfill. The sum of all these emissions over a period of 21 years represent a total of 53.2 tons of CO2 equivalent. The composting process also generates some greenhouse gas emission, which was estimated to 6.9 tons of CO2 equivalent. So a total of 46.3 tons of CO2 equivalent was avoided by the decentralized composting plant, which represent 87% of the baseline emission. All these figures can be seen in the figure 10. Next, please. In conclusion, it can be noted that the compost production rate in this region is 24%, and for each ton of organic waste composting, 140 liters of water is consumed, and 1.8 liters of leachate are generated. This information represents good estimate that could help to design and operate future decentralized composting plants. The compost produced have a very high water content and a low heavy metal contamination. So these composts can be used as input material in local agriculture. Regarding the greenhouse gas emission reduction, this study revealed that 87% of the baseline emission can be avoided by decentralized composting plants. So these plants represent a good mean for sub-Saharan African countries to reduce their greenhouse gas emission in order to reach their intended NDC taken at the COP21 in Paris. Next, please. Next, please. To finish, I would like to thank the Volkswagen Foundation who founded this research and my own institution, namely the Swiss Center for Scientific Research in Côte d'Ivoire and the Félix Houphouët-Boigny University. Thank you for attending. Thank you.
Thank you so much for such a nice presentation, Yeo, and good insights. Also, many, many thumbs up to you and your work, what you've been doing. So let's move to our next presenter. We go to Lebanon this time. Our next presenter is Sarah Mahfouz, and her presentation is on improvement of construction and demolition waste management using waste glass in hot mix asphalt. Sarah is a master's student doing her research about utilization of glass filler from Beirut explosion in an asphalt pavement in Beirut Arab University. Sarah gonna have her presentation in video, so let's watch the video, and she will join most likely during our Q&A in live.
Hello everyone, my name is Sarah Mahfouz. I'm from Beirut Arab University, studying master degree in civil engineering. I will talk today about the improvement of construction and demolition waste management. Hello everyone. I will talk today about the improvement of construction and demolition waste management using waste glass in hot mix asphalt. These are my presentation outline. So Lebanon is drowning in its own waste. Lebanon has experienced a history of destruction and at the same time of development since 1975. And the construction requires sand and gravel, which are met through removal of sand from coastal strip and through quarrying in the mountains. On the other hand, 1,000,000 tons of waste is generated each day around the world. Landfills are used to dump most of this waste. Lebanon has been facing many environmental problems. One of these problems or issues is the huge number of solid waste. After the 4th of August blast in Beirut, huge quantities of glass were managed on site to landfills. After my participation with many other volunteers with the UNDP in the waste management project assessment of demolition waste quantities in Beirut due to the blast, the UNDP reported that the estimated glass waste from Beirut blast was 20,000 tons. So we have an urgent need to reduce this type of waste. The world is in need to conserve its resources and determine innovative ways to recycle waste to ensure sustainability. The concept of recycling waste has created a large sector for research. And researchers from various organizations have explored different types of waste material with the green material technology. Nowadays, the increasing environmental concerns and the increasing in cost of standard fillers, cement, hydrated lime, and stone dust motivates investigators to use glass waste. This research presents laboratory study to assess the use of a glass powder as possible replacement to limestone filler and asphalt concrete. Our research objective. First of all, we need to know that most highways are flexible in types. As statistics show that 95% of the total highway of the world are made of asphalt. Asphalt is composed of aggregated, coarse, fine filler, and binder, which is the bitumen. And aggregate form 95% of the total asphalt mix, which indicates that the introduction of alternative aggregate in the production of asphalt concrete can help to create sustainable practices. Our first objective is to evaluate the variation in optimum binder requirement to determine the optimum percentage of glass powder to be used as aggregate replacement without reducing mix's performance. We want to involve glass waste in circular economy industry and minimize the solid waste. Our methodology, first, the material processing. Collecting glass, then crushing it and sieving it into powder. And we have done the specific gravity test for glass and found that the specific gravity of glass is 2.4, which is less than the limestone specific gravity, which is 2.6. Then we prepared the asphalt mixture as the glass powder was replacing filler aggregate in two different percentages, 25% and 50% of by weight of filler aggregate. The mixes were with different binder content, 3.5, 4, 4.5. We find the optimum binder content for every replacement and to be acceptable with the 4% percentage void. Hello everyone, my name of the total asphalt mix performance. We want to involve glass waste in circular economy industry.
Apology for any technical issue, but I think it's...
Yes, but...
Yes.
Hello everyone. The material processing, we collect the glass from explosion area by individually crushing it in the lab and then sieving glass aggregate into filler, as filler is the finest particles of aggregate that passes through the sieve 0.075 millimeter. That means it retains on the pan. Two types of glass were mixed when collected, the security laminated glass and the flat glass. The testing, we have done the dynamic models test, which represent the stiffness of the asphalt material with different repeated load tests at different frequency and at different temperature. The Cantabro test is a test that measures the breakdown of compacted specimens using the Los Angeles abrasion machine to find the abrasion loss of every sample. The research results, so as we can see in the first graph. Hello everyone, my name is Sarah Mahfouz. I'm from Beirut Arab University, studying master degree.
Apologies, I think it's on our side, this video. I think it's somebody is touching. So if someone is touching the video, please do not touch. Apologies. I hope we can move on.
Was 2.31, decreasing with the increase of the replacement of glass powder. Here we can see that when we have less bulk density, then we have a reduction of construction cost. Regarding the dynamic modulus, in the graph of dynamic modulus, the low frequency represents the high temperature, and you can see that the values at high temperature are very close. So it's acceptable to use it to use a glass powder in asphalt in hot weather, and it's still acceptable to use it in cold temperature at cold temperature. So we have a replacement of replacement by glass powder with acceptable dynamic models to resist fatigue and rotting. Our results are the reduction in bitumen content with 25% replacement. As we can see, that the optimum bitumen content of the control mix was 4.6%, but it decreased when we replace the limestone filler by 25% glass powder, it is 4.1%. We can see that 25% replacement is an optimum replacement. Otherwise, we can reduce the filler aggregate in asphalt by 50% and done a reduction of unit weight of asphalt samples. Finally, it's acceptable to replace limestone filler by glass powder in asphalt mixture with less unit weight, minimizing glass waste, and less bitumen content with acceptable mechanical properties. Our challenges, we faced many challenges. Our challenges were the fuel and diesel problem in Lebanon, leading to delays in our testing. And the circular economy is an economic system aiming to minimize the waste and making the most sources. In contrast to the traditional linear economy, no more take, make, dispose. We will take, make, recycle, and reuse. And our future scope is to conduct life cycle assessment and life cycle cost assessment. This is everything. I would like to thank my advisor, Dr. Hussein Al-Qasim, to help me in my first stages. And this is everything. I'm ready for your questions. Thank you.
Apologies for delay, but thank you so much, Sarah, for your video and your insightful presentations and the project you've been doing. Also, many, many thumbs up. But unfortunately, now we have to move to our final presentation. We have Olas Noya from Spain presenting her work on use of waste biomass as a secondary raw material in the manufacture of anodes for ion batteries. Olas is an environmental scientist with a master's degree in environmental engineering from University of Basque Country. Olas, floor is yours.
Hello, many thanks, Maria. First of all, thank you to the ISWA for this opportunity. My name is Olat, as Maria said, and today I'm going to make a presentation about the research I did in collaboration with the University of the Basque Country. I hope you find it interesting. It is about the use of waste biomass as a secondary raw material in the manufacture of anodes for sodium-ion batteries. Okay, as an introduction, it is interesting that my investigation was based on a new ways to store energy in a more sustainable way. But why is this important? There are two main reasons. One is the waste and the other is the energy. About waste, this experiment makes it possible to take advantage of organic matter from large generators of organic waste such as agriculture. As you can see in the first graphic, worldwide, more than 80% of the materials ends up in landfills or incinerated. So this could be a way to introduce the circular economy in both agricultural and energy sector. About energy, the increase in global energy consumption is undeniable. However, with the introduction of renewable energies and the conditioning by the climate, improving energy storage will be indispensable. The most common form of energy storage in this moment is the lithium-ion batteries, but lithium is a limited chemical element in the earth, so it's necessary to consider an alternative to these batteries. That is why, in this case, the study has been carried out with sodium-ion batteries. Sodium raw material is more abundant and easier to extract, which offers the opportunity to develop cheap and high-performance cathodes. But there is another problem, that in the case of the lithium-ion batteries, the anode material used is the graphite, which forms a uniform layer structure with a fixed spacing that allows lithium to be intercalated in each carbon hexagon. You can see it in the picture in the left. But sodium's ionic radius is bigger than lithium, so it cannot be inserted between the graphite sets. This is why different carbons are being studied as an alternative. For it, residual biomass coals have been studied. They could be of two types, the hard carbon and soft carbon. In this case, the hard carbons have been selected as the most interesting ones, as they are not graphitable disordered carbons with a much more complex molecular structure than the ordered structure of graphite. So the sodium can search between the graphite space. The hard carbon is usually processed from the carbonization of saccharose. However, it is possible to obtain this type of material by carbonizing other types of precursors, such as those that are going to be studied now. Okay. On this, it was the old one, so I want to explain it. Three types of biomass are going to be studied, all of them generated in a large volume in the agricultural sector. They are the residues from wine, from olive oil, and for cider production. So they are grapes, olives, and an apple. For them, different kind of treatment has been made. The first one, the direct pyrolysis, has been done for all the biomass samples. This consists of carbon generation in a high temperature and low pressure. We use in all samples, so in three kind of waste. Then just for the grape one from the wine, we add two pretreatments: the acid treatment with phosphoric acid to improve the structural order of carbonized materials, and the hydrothermal treatment, which is a biomass conversion process in which organic matter is transformed into something similar to lignite product. And then the mixture of both the acid and the hydrothermal. To end, all of the pre-treated samples have been passed for to the pyrolysis. Okay, here you have how I prepare the batteries. For the preparation of the anodes, the biomass carbonized were mixed with conductive carbon black and polyethylene fluoride in that proportions in the picture. The mixture was used to create a laminate in a machine like the one you see in the picture also. Once the laminate was dried, the circular electrodes were obtained from the laminate using a punch, also in the picture, and the batteries were assembled in a glove box in an argon atmosphere, low pressure and in absence of oxygen and water. And finally, the storage capacity of each of the batteries was measured in a galvanostat at room temperature. Okay, here you can see the results in the galvanostat. This is in the first graph, you can see the charge and discharge capacity of the batteries. The two results have been identified, the reversible and the irreversible capacities. The interesting one is the green color, where as you can see, we obtain results over the minimum in two occasions. The battery with carbon anode obtained from the direct pyrolysis of apple biomass, and a grape biomass pretreated with hydrothermal treatment. In the other graphs, it can be seen that the experiment has been carried out for different charging and discharging speeds from 1 hour to 15 hours, obtaining as a conclusion that the longer the hours, the better the charging capacity. So we have already seen that the results are favorable, but in the research, we wanted to make sense of these results. And for this purpose, different analyses were carried out on the biomass use. The first analysis was the analysis of precursors, I mean the raw biomass. The analysis done were the immediate and constituent analysis on dry basis and elemental analysis on wet basis. As you can see in the table, we obtain a lot of information from this analysis, but we are only going to speak about the most relevant. The most interesting data provided by the immediate analysis is the fixed carbon of the samples, as this provides information on the carbonization yield of each sample. In this case, the bio-waste that will generate most carbon will be the one from wine production. Also, another way is the high ash content of olive sample, which could be something negative. And finally, as a result of constituent analysis, I'm going to highlight that large amount of lignin contained in grape sample, as it is the basis of the carbon structure. Okay, we analyze also the structure of the carbon throughout the X-ray diffractor. As you can see in the slide, there is a lot of information which is difficult to explain just in a few minutes. So I will try to sum up in the most important information. From the diffractograms obtained in the X-ray diffractor and using Bragg's law and Setcher's formula applied to this type of course, we have calculated the structure parameters presented in the table. The most important information is the D0002, the first column, which is the spacing between graphitic planes. The use of different treatments identifies that the phosphoric treatment as the one that has a slightly larger interplane spacing than the rest. But in any of the cases, the interlinear spacing is always larger than in graphite. Okay, several spectrals have been performed on each gold material in order to obtain data of the homogeneity of the sample. It has also been observed that when different treatments are applied, the sample is increasing in disorder, but as there is a waste, they are all very heterogeneous.
Okay, the last analysis we did was the picturing of the materials of the scanning electron micrograph SEM, which shows us the structure of the carbons. The conclusions obtained from these pictures that as these coals are obtained from biomass residues are homogeneous structure. Also that the hard carbons ensure that the structures they show are the angular ones, so the grapes and apples are more hard carbon and not the olive one. And finally, in conclusion of this research, we have demonstrated that the applicability of waste biomass in the generation of battery anodes. All three types of waste have worked as anode for sodium-ion batteries, with apple waste giving the best results in terms of charging and discharging capacity with direct pyrolysis, but the most effective treatment test only on grape samples is the hydrothermal. And due to the lack of time, it was not possible to test the three treatments on the three types of biomass, but it has been shown that the cider production residues, perhaps with hydrothermal treatment, can give very competitive results. That is what we have to investigate now. I hope my presentation has been of your interest, and if you have any doubts or questions, you can contact me from this chat or also via LinkedIn. So thank you very much for this opportunity.
Thank you so much, Olat. This has been so interesting as well. Many, many thumbs up. But now we are ending, and our dear presenters, you can put your cameras on, your mics also on if you feel like. We have some few minutes left for Q&A. Actually, we have more than 5 minutes, maybe 7, maybe 10. I don't know. Navarro, you stop me. This gets exciting. But I would like to ask first from Andrea a question that would you say that once you have set up a eco-work space, let me restart my question basically. Would you say that once you have set up an eco workspace and one can just take a concept and replicate it or in such a participatory approach, or you always, you need to have this participatory approach, or you can do something else?
Thank you for the question. Well, the vision of EcoWork is that we can replicate this model. So we showcase it in Delhi and then replicate it, being it in Delhi or worldwide even, or even to adapt it to other waste streams. And I think it's always needed that you have this local connection. So a participatory approach will always be needed, but maybe not to that extent as we have it now. So I think you can learn a lot from the pilot that we set up, but then it always needs to have some adaptation to the local community, and for that also the people on the ground.
All right, thank you. And a question to Iris. I have about the classification of SRF that you found in your research. Have you made an estimate of the percentage of energy demand that these SRFs could cover as an alternative fuel, particularly in cement plants?
Thanks, Maria. Yes, it has been estimated that the use of non-recyclable plastic and cardboard from municipal solid waste can provide on average about 2 billion megajoules of energy for cement kilns, solving about 1 to 5% of the solid waste management issues and covering about 8 to 23% of the energy demand for cement production in Bolivia. And these results are very interesting for estimate the potentialities of SRF in Bolivia and Latin America. Thank you.
Interesting, thank you. I would like to ask also a question from Yale. Why your research focus on decentralized composting? You're unmuted. If you can press a mute button, a mic, and below.
Hello.
Yes.
Hello.
Yes.
Okay.
Perfect.
So in sub-Saharan Africa, we have several initiatives of centralized composting. But all these initiatives have failed because of technical issues and also because of the bad quality of the compost produced on this plant. So now we have focused on decentralized composting as an alternative to composting in this region. Thank you.
All right, thank you. And we have a next question to Sarah from Piotr Barzak, in the questions box. He was asking, is the use of glass as an asphalt considered as recycling of downside or downcycling? Is there a glass recycling industry in Lebanon that recycle bottle glass or bottle glass? That was his question.
Yes, in fact, the recycling of glass is not making it low quality. We are making an asphalt mixture, which will be used to make it more sustainable. We will use glass to make asphalt more sustainable. And in my project, I'm using laminated glass and windows glass from demolition waste, which cannot be recycled like bottle glass. Because they have a different chemical composition and temperature of melting. Yes, we have many industries that recycle bottle glass in Lebanon, but it's not our issue target. Thank you.
Thank you, and I hope, Piotr, you got the answer. You also had a question to Olaz, that it seems the biomass for the process is industrial waste. Is it possible to use post-consumer waste by extracting sodium and sugars?
Hello, thank you for the question. Yes, I think that it is possible to trial the very different forms of creating the anode. So you can try we just start with something that is in a very early state of testing. So there's the opportunity to create or to try different options just now. So thank you for the question.
Thank you. And thank you all to this session. I think we're closing up, and Navarro, floor is yours. You are welcome. What a pure joy, hey. What a session. Something I've learned. So much I learned. So I hope you all too, across the world.
Thank you. Thank you very much, Maria. Very nice presentation. You did a really great job here coordinating all the session, though the technical issues for the videos. I really enjoyed hearing from other parts of the world, from RDF to social inclusion of informal waste speakers, composting, and advanced technologies for the recovery of the organic waste fractions, as well as this recovery of glass. So we are speaking about a very wide topics in relation to circular economy, recycling, waste to energy. It is really interesting, and I think that this session was really, really great. And I would like again to say thank you to all the speakers to join us and to be part of this conference. It will be very, very difficult for us to find the winner of the first ISWA YPG online conference. So best wishes and congratulations to everyone. And now we can say that the session is closed. We can finalize it with a brief break of about 5 minutes. So after this session, we will have another session, and the fourth and the last session that will be moderated by Aziz Islam from the United States of America. And so we can have 5 minutes break. So let's see us in 5 minutes at 3:45 Central European Summer Time. Please stay with us. So here we are for the first and last session of the ISWA YPG online conference. So welcome everyone again. And we are about to start our new session. Please welcome Aziz Islam to the stage. Thank you to be here with us. Only for introducing you, Aziz. Aziz has recently completed his PhD from the University of Texas at Arlington in the USA. So congratulations, Aziz, and welcome here to the platform. And thank you very much to join us here to moderating this session. Please, the floor is yours. I hope you all good luck.
Thank you very much, Navarro. Thank you. Thank you. Hello, everyone. My name is Ajijul, and I'm delighted to be moderating this session. We are very lucky to be joined by 7 speakers from different corners of the world. 4 of them will give a full presentation, while 3 will give a poster presentation. Then we will have a short question and answer session. Please remember to submit your question throughout the presentations through the questions panels. Also, please include your name, your state, and the person you want to answer the question. So, I would like to welcome our first presenter, Rafaela Madeiras from Brazil, whose presentation title is Oxidative Cover Layer as an Alternative to Reduce Landfill Gases Emissions in Developing Countries. Rafaela is a civil engineer from the Federal University of Pernambuco. Rafaela, the floor is yours. Please.
Okay, thank you so much. Hi, everyone. Good afternoon and good morning. And my work is on oxidative cover layer as an alternative to reduce landfill gas emissions in developed countries. So, the global concern with the climate change and the emissions of the greenhouse gas is not new. There are many goals, agreements, and actions to keep the global average temperature below 2 degrees above the pre-industrial levels. And when we see the situation in Brazil, as we can see this first figure, is we compare the years of 2010 and 2019, and it's possible to note the increase of the emissions of CO2 equivalent. The biggest improvement was related about the industrial process. About the sector waste, the last one here, it's possible to note the increase was about 1.3%, and this revealed to us an amount of 96 million of tons of CO2 emitted in 2019. The final disposition sites for municipal solid waste in Brazil in 2019 was responsible for around 2.21 million tons of methane. And when transform these in millions of tons of CO2, we can see in this figure too that the landfill disposal was responsible for emitted about 35 million, and the disposal on uncontrolled and landfill dumps was responsible for emitted about 26 million of tons. Here. So there is a necessity to looking for solutions and techniques to decrease the greenhouse emissions. And one of them is the oxidative cover layer, and can be used to places that received the organic material, solid waste, and for small and medium landfills, and also to dump sites in a closed process. The oxidative cover layer is a mix of 2 materials. We use the pure soil and the organic compost, and we mix them. We give the soil the methanotrophic bacteria responsible for the oxidation of methane, and the support to the community still continue and working. We mix these materials because we need to attend some criteria about the geotechnical area. Here we have the equation that represents the process. We have C, the methane gas produced by degradation of organic material in landfills. And in the presence of oxygen, we can convert this methane into CO2 and water. And this is important because CO2, carbonic gas, is a little less dangerous than the methane. Here we have the representation of how this layer working. And we have the waste layer, that's responsible for the production of the landfill gases, a layer of coarse material, and this is responsible for the distribution of the gas. And the last one is the biocover or oxidative cover layer. And this is when the transformation, the process occurs. This is necessary combination of these two aspects, geotechnical aspects and the bacterial aspects, because, for example, if we have the biggest quantity of oxygen in the layer, this will have the process of oxidation. But on the other hand, the high level of the porosity in this layer, this will result in a bigger quantity of rainwater into the solid mass, and also this will result in a biggest quantity of leaching to be treated, and for developing countries, this is not cheap. We have been working in my master thesis with 2 different soils, 3 different composts, and a mixture of them, as you can see here. And then I've been working with 11 different materials. And as the time is a little short, I will present only one of these materials and their mixtures. Here we can see some results about the geotechnical part, and it's possible to note this graphical one. We have the granulometrical curves, and we have the 7 different materials here. And when we finalize this classification, it was possible to note that the soil pore, the Igaraçu soil, is classified as a sand clay soil. The both organic compost were classified as sand, and all mixtures were classified as a sand clay soil. When we analyze the Atterberg limits in these 2 columns, the 2 first, it was possible not the liquid limit happened a decrease in these values. This is what happened because the size particle. Also, this reflected in the plastic index that decreased too. And about the grain density, we can note that the 3 values of the organic compost is lighter than when we compare with the Igaraçu soil. This happened because the material organics is a little heavier. And for these mixtures, it's very important to us because we have to work with these materials and weight and not in volume. This is a difference. In addition, the Proctor-Compactor test was realized for all samples, and as a result, it was obtained the optimal moisture values of the mixture present in a lower dry soil density values than the poor soils, which differs with the soil permeability, as you can see in this graphic too. Mixed 1 is the line pink, 2 is black one, and the third mixed 3 is the blue one. So when we analyze the particle size, the highest optimal mixture, as you can see here, and the lowest dry densities of the mixtures, this is a result. The void radius is increased, and this results in a bigger value of aeration. What helped the layer to oxidate the methane. As a result of a part of chemical and chemistry experiment, it was possible to analyze that the pH value increased about 7.4 and 7.8, a range that favors microbial activity. Concerned about the carbon and the nitrogen and the relationship about them, it has been noted that the addiction of the organic matter provided conditions for the soil to support accumulation of methanotrophic bacteria. And about the optimal relationship between carbon and nitrogen, it was reported that in the other research that the bigger, the better. As a conclusion, the work is still some doing in lab. We have that main adaptation and mitigation technologies can contribute to the greater climate change scenario, but no one single option is sufficient by itself, as one of the alternatives to decrease the greenhouse gas emitted in the atmosphere is the oxidative recovery layer to landfills and websites. The addition of the organic matter gives the soil the condition to support the growth of methanotrophic population, resulting in methane oxidation. The importance of studying those layers is highlighted mainly for the applicability in developed countries, both in landfills and for the remediation of them sites, such as in Brazil, which still has 3,000 areas with inadequate disposal of municipal solid waste on Activa. So thank you so much for your time in your attention.
Thank you, Rafaela, for your excellent presentation. Actually, the concept was very important to use the oxidative cover layer for controlling the landfill gas emission. So thanks again. We will now be hearing from Ana Maria Rodriguez de Castro from Brazil, whose presentation title is Analysis of Guidelines for the Disposal of Masks in Brazilian States During the Pandemic. So I think this presentation is really important in the context of recent COVID-19 pandemic. So Ana is an environmental engineer and she is currently a PhD student at the Hydraulics and Sanitation Department, University of Sao Paulo. So Ana, the floor is yours.
Thank you. Hello, everyone. So I am Ana Maria. I'm a researcher at NEPE, which is a research group focused on solid waste at USP. And today I will present a research about mask disposal in Brazil. Since the pandemic started last year, we are facing several new situations, and one of them is the need to wear masks to protect ourselves from coronavirus. Because of that, there was an increase in the consumption and disposal of this protective equipment, which were more common in healthcare and industrial waste, but now they are part of urban solid waste as well. If this waste is not properly managed, they can cause environmental pollution, as we are seeing in the streets, in rivers, in parks, and they can also put public health at risk if they are contaminated with coronavirus. Instead the relevance of this subject, the federal government didn't create any legislation or even guidance about the disposal of masks. And because of that, each Brazilian state has approached the matter differently. Considering that, our objective was to analyze which guidelines the Brazilian states are given to their population about the disposal of masks. We carried out a documentary research. So for each Brazilian state, we searched first on their official government website and then in their environmental department website. We selected all documents related to solid waste management during the pandemic, published between March, when the pandemic started, and September 2020, when we carried out the research. We found 120 documents, but only 8 of them mentioned masks. They were published by 4 states, which is a small number considering we have 26 states in Brazil. 2 documents didn't have any guidelines about the disposal of masks. They were just describing some government actions. The first one was about the production of reusable masks to avoid the generation of more waste. And the second was about an environmental event where there was a lecture on masks and healthcare waste. And the other 6 documents actually had guidelines, so we moved further to analyze them. The main recommendation we found on those documents was to place masks in plastic bags, close it, and put it in another plastic bag with common waste. This is an expression for mixed household waste with organics, rejects, and even recyclable materials if people don't segregate their waste at home. Actually, this is really common in Brazil because we don't have selective collection in all the cities. And the main destination for this kind of waste is final disposal in landfills or dump sites. Dump sites are prohibited in Brazil, but they still exist in many cities. And the big problem with this kind of recommendation is that we have a lot of waste pickers working both in the streets and in dump sites, searching for recyclable materials, opening all these plastic bags, and if there is any contaminated mask inside these bags, they will be at risk of contamination. To avoid that, 3 documents ask the population not to put their masks with recyclables, and another one requested a 46-hour quarantine before putting masks with common waste for collection. But there was no reference why 46 hours and if it's enough to kill the virus and which research they considered to give this kind of recommendation. We concluded that state and federal governments have not published enough information about this important subject, and because of that, waste workers are at risk of contamination, especially waste pickers because most of them work under precarious conditions without protective equipment. In addition, there was no information about the destination of this common waste with masks. But considering the main destination for waste in Brazil is final disposal, and that we have a lot of dump sites open yet, imagine the amount of masks that are being discarded in dump sites and all the pollution and contamination they can cause. To solve all these problems and give a right destination for the masks, we think a possible solution could be a creation of a reverse logistics system for masks supported by legislation as we already have in Brazil for wastes like medicines, pesticides, batteries, among others. In this case, consumers would have to return their masks after a quarantine to the producers, so they would give them a right destination, and the government would act inspecting and providing information for everyone about the reverse logistics, so providing environmental education. In this way, each part would have responsibilities and together they would be able to improve waste management and resolve these masks problems. So that's it. Thank you for your attention. Here is my contact and the website and social media of my research group, NEPE.
Thank you very much, Anna, for your insightful presentation. A reminder to the audience to keep submitting your questions for us to come back to at the end of the session. So let's move to our third presentation. Ladies and gentlemen, now you will be hearing from Ashpreet Kaur from the United States of America, whose presentation title is Zero Waste Policy Evaluation of College Campus, a case study of University of Florida. Ashpreet is a third-year PhD student of interdisciplinary ecology at the University of Florida. Ashpreet, the floor is yours.
Hi, thank you. Good morning, everybody. I'm gonna start right with the background. Just like climate change, waste management is a rising concern and plays an important role in mitigating climate issues. Education is also known as an important indicator in bringing change in the attitudes and behaviors. And hence, universities are a great place to implement a policy as they can set examples for the other institutions on how to follow a policy. The objective of this study is to identify the existing waste minimization and diversion programs on a campus and analyze the situation for a possible implementation of a zero waste plan or a policy. I will discuss about the zero waste initiative proposed by the University of Florida in 2005. An institution is called a Zero Waste Institute if it is diverting 90% or more of its waste from landfills. The data was collected by conducting 1-hour interview with the coordinators of the sustainability department, online newspapers, articles, documents, and a university website was also studied via content analysis, and then the themes were produced under which the data fitted. So, University of Florida is in Gainesville, Florida, and founded in 1853. The size of the campus is 2,000 acres, and around 8,500 students reside on campus. The enrollment of students in 2019 was 49,555. The stakeholders for whom the study is important are the Office of Sustainability, Facility Department, Planning, Design, and Construction, Contracted Waste Haulers, Athletic Association, UF Health, and Gator Dining. So the current situation of UF suggests that there is no zero waste written policy on campus, but they were thinking about it in 2005. But despite of this, they do participate in ASHE, which is the sustainability rating system for higher education institutions in USA, and get scored for their waste reduction and diversion programs. The food waste at the UF dining is sent for composting at the Watson C&D and County Line landfill in Archer, Florida. Recyclables go to the county's Clavita Brown transfer station, and there are a lot of educational courses around sustainability and sustainable changes are being done at the university, especially in the dining. So the divertibility analysis shows that in the year 2009, the waste that was recycled was maximum, and it was around 9,000 tons. And maximum waste was landfilled in 2017, which was again around 9,000 tons. And this is a waste characterization, and this figure suggests that the yard waste is one of the most produced wastes, which is followed by the food waste, plastic, and paper. So to analyze the policy implementation, Hudson framework has been used. It has 4 steps: policy preparation, policy tracking, policy implementation, policy implementation support, and implementation review. So the findings suggest that there is a lack in the policy preparation, and zero waste policy was never a written policy and never made official, which shows that there is a lack of interest among the administrators regarding the waste issues. There is also a lack of resources and finances, showing lack of support from the officials. The stakeholders, they don't collaborate with each other or don't communicate with each other. The communication is not strong enough, and hence the waste management is not being monitored holistically. The number of the waste diversion recycling percentage is not available, and this lack of data suggests that there is a lag in the policy tracking. The officials suggested that there's a need of composting initiatives to increase their waste diversion. So some of the areas of improvement for the university are that first and foremost, it should have a written zero waste policy and have a plan to follow it as a part of their climate action plan. Waste diversion and reduction can help the university reach its greenhouse gas emissions goal. Zero waste goals for organic waste is needed, as it is a sector from which major food waste is produced. Stakeholders also need to work and communicate with each other for better policy implementation. Market assessment needs to be done for recycling to understand what can be recycled in the Florida market and what is not recycled. There needs to be reuse and composting programs set up on campus to minimize and reuse as much as possible. Some of the next steps for this study are to compare other universities with UF and their zero waste activities and goal to do a comparison. And more stakeholders from different departments should be interviewed to get a holistic picture of the university's waste diversion and management. That was my presentation, and thank you.
Thank you, Ashpreet, for your informative presentation. Ladies and gentlemen, now we come to our fourth and final full presentation of this session. Please be reminded that after this presentation, we will have a poster session, and after that, we will have a short question and answer session. Now, let's welcome to our fourth presenter, Laura Stone from Spain, whose presentation title is Innovative Technology in Bio-Waste Recycling to Overcome Challenges in Anaerobic Digestion from MSW. Laura is graduated in Business Administration from Universidad Pontificia Comillas with 2 years at the University of Northwestern Ohio. Laura, please, the floor is yours.
Hi. Thank you very much, Aziz. Hi, everyone. Thank you for joining in today. Hi, ISWA. Thank you for giving me the opportunity to present at this event with all my colleagues from all around the world. My name is Laura Stone. I work at the business development team at EconWard, which is a Spanish R&D company that has developed a technology to optimize the recycling and recovery of the organic fraction of municipal solid waste when treated through an anaerobic digestion process. So I'm going to firstly speak about the existing challenge there is to treat the organic fraction of municipal solid waste through AD. I'm going to talk about what our proposed solution is, which is based on a pre-treatment through a high solids thermal hydrolysis process. And then I'll follow up with the research and results from the last 4 years and what the conclusions that we've extracted are, which are essentially that this technology is a financially and technically viable solution for the existing challenge. So what is this existing challenge? Well, on the one hand, we've got the organic fraction of municipal solid waste, which is the greatest waste fraction within municipal solid waste and probably the most complex to recycle and recover efficiently. So we have countries trying to fight climate change who have established recycling targets that need to be met. And they've made it a priority to tackle this fraction of the waste and reduce landfill disposal to avoid GHG emissions. So on this other hand, we've got anaerobic digestion technology, which has been proven for the last 2 decades is a preferable alternative for bio-waste treatment, especially when it comes to the wastewater sector and the agro-industrial waste. And it's been proven to be an efficient way to recover waste, to recover organic waste streams and create biogas. So this is renewable energy from it. So the existing challenge is bringing these two ideas together. When we try to do anaerobic digestion from the organic fraction of municipal solid waste, what we find is that this waste is very heterogeneous, it's very season dependable, and it's highly polluted with many contaminants. Even when we're talking about source separated organics, it's full of cans and plastics and batteries and so on. So what this causes is a very problematic lack of stability in the process, in the AD process. And this translates into high operating costs, low biogas production, low biogas quality, and a very unclean digest state that is not really suitable for land application. So as a solution, what we've developed is we've come up with a high solids thermal hydrolysis process to be used as a pre-treatment for this waste stream before the AD. So thermal hydrolysis, as most of you might know, is just applying temperature and pressure through saturated steam to the waste. So it essentially works like a pressure cooker, right? So this is not innovative on its own. The innovation comes in being able to have developed a technology that works in a semi-continuous way and that can withstand the abrasive and corrosive characteristics of this input material, which in this case is the municipal solid waste and similar waste streams, such as the residuals, such as the green waste, right? So when we process this incoming waste through this technology, which the company's called for commercial purposes the biomac, what we come out with is an optimal substrate, a biomass, which is ideal for the AD process. So this biomass has 3 main characteristics, which are it's homogeneous, it's chemically degraded, and it's sanitized. So homogeneous means that the organics within that waste stream have all blended together And nothing really happens with thermal hydrolysis to anything that's not organic. So the contaminants that we were talking about earlier on are just left as they are when they come out of this process. So that makes it a lot easier to separate them efficiently from that waste stream before the substrate goes into the AD. So then secondly, this substrate is chemically degraded, and this brings higher stability to the AD process and higher biogas yields. And then lastly, it's sanitized, which means it's free of pathogens, both the biomass and the resulting digestate, making it a lot more suitable for land application. So how do we come up basically with this idea of creating an optimal substrate for the AD? Well, for the last 10 years, EconWard has been carrying out lab scale and semi-industrial scale testing. And then for the last 2 years, we carried out industrial scale testing. We built an industrial scale facility in Madrid, and we processed the municipal solid waste for Madrid City Council. And this municipal solid waste contained on around 66% of organics. So that means about 34% of them, of this waste stream, was contaminants. It was plastics, it was cans. In fact, if you look at the photo on the bottom left of your screen, well, you can see you probably can't zoom in, but if you could see that that's the waste as it was received at the facility. So it's mainly food waste and some green waste, but there's cans, there's plastics, there's textiles, and then the second picture is one of the autoclaves of the equipment. So when it's processed through that autoclave, that's the third picture, that's the raw biomass that comes out. And you can still see the bits and pieces of the plastics and the other contaminants. But what happens is now all of the organics have blended in together. So when you process it through a general standard industrial separation equipment, such as the fourth picture on the bottom screen, what you get is a biomass, which is a lot easier to separate those light residuals from, which would be the top half of that last picture. And that biomass at the bottom is a pure organic biomass, over 98% organics, which is now ideal for the AD process. So we carried out this industrial scale testing, carried over 1,500 analyses, and everything was certified by external bodies. And what was certified is the stability and the robustness of the equipment and the process, which allowed us to demonstrate all these improvements for the AD that we're talking about. So just to share with you a few of the key results that we came up with, essentially, we increased the specific biogas production. So that's more biogas per ton of waste, of incoming waste. We increase the methane concentration in the biogas flow. So that's better quality biogas. And due to the fact that this substrate is now easier to digest in the AD, we can work at lower retention times, lower hydraulic retention times, which increases the capacity of existing facilities. Then, like we spoke earlier on, we increase the separation efficiency of standard separation equipment, minimizing organic loss in the process. And then probably one of the key aspects of our findings is the extraordinary degradation of COD and volatile solids, which is on average around 85% in all cases. So lastly, we get a higher quality digestate, sanitized, hygienized, easier for land application. And when you take all these 6 benefits, right, and you monetize them, what you get is higher revenues for these facilities due to the increased capacity, due to the increased energy production, and the reduction of operating costs. So all in all, right, as a conclusion, we've come to establish that this semi-continuous autoclaved thermal hydrolysis process offers a technically and financially viable solution for the recycling and recovery of the organic fraction of municipal solid waste in AD. So I like to say that this technology is a triple impact technology because it helps achieve environmental goals like GHG emissions avoidance, meeting organic recycling rates, helping decarbonizing the economy. It's a financially viable solution due to the increased biogas production for these facilities and lower operating costs. And it achieves social engagement through regulatory compliance and innovation based on sustainability. So overall, we believe that this biomass technology is an innovative solution to allow AD facilities to treat the organic fraction of municipal solid waste and improve the recycling and recovery of this waste fraction worldwide. So thank you very much. Happy to take on any questions later on. And you've got my email for anything else. Thanks.
Thank you, Laura. The presentation was really very informative, and you presented such a good technology for overcoming the challenges in anaerobic digestions. Now we move to the poster presentation followed by a question and answer session. In this session, the speakers have 3 minutes for introducing their key findings and results. The first poster presentation will be introduced by Davide Bartasani from Italy, whose presentation title is Single Cell Proteins Productions from Effluents of Confectionery Industry by Saccharomyces cerevisiae. Davide is a second-year master's student in biotechnologies for bioresources and eco-sustainable development at the University of Verona. Davide, the floor is yours.
Thank you. Hi, I'm Davide Bertasini, a master student of biotechnology from the University of Verona in Italy. Now I show you our recent work about single-cell proteins production from effluent of confectionery industry by Saccharomyces cerevisiae. It is estimated that the human population will rise to 10 billion by 2050. So the food demand will be higher than now, and in particular protein demand. So when we think about protein production, we think about the zootechnical activity that is not a sustainable system because it uses the 70% of fresh water and the 40% of land, and also it releases large quantities of greenhouse emission. So we have to find an alternative sustainable source of protein. One of the most important alternative is microbial protein, that is also named single-cell protein, because we can grow this type of cell not only on pure substrate, but also on organic waste or wastewater from alimentary industry. So in this work, we try to grow Saccharomyces cerevisiae, a common yeast, on an effluent of confectionery industry and agriculture digestate that is rich in nitrogen and phosphorus. So we used the filter press to remove weak particles from the substrate. Then we did the preliminary test on batch reactor to find the best condition for Saccharomyces cerevisiae, aerobic or anaerobic. So we use this condition on continuous test with different dilution factor from 0.05 to 0.9 on days to find the maximum yield in biomass and protein. We estimate the biomass concentration with microbial count and the nitrogen concentration with the Schendel method. We found with a preliminary test that aerobic condition is better than anaerobic one, so we use this condition on continuous test, where we found that the best dilution factor was 0.2 on days with a protein productivity of 2.9 grams per liter day. After that, we calculated the kinetic parameters that are very similar with literature values, like the production of single-cell protein by Saccharomyces cerevisiae on glucose and ethanol. And finally, we did the amino acid profile analysis, and we found that our cells are rich in essential and non-essential amino acid. And these values are very interesting for production of an aquaculture feedings. So thank you for your attention, and I'm done.
Thank you, Davide, for your informative presentation. The second poster presentation will be introduced by Ana Paula Gonçalves from Brazil, whose presentation title is Challenges of Commercialization of Post-Consumer Plastic Packaging Faced by Waste Pickers in Brazil. Ana is a biologist and a master's student at the Hydraulics and Sanitation Department, University of Sao Paulo. Ana, the floor is yours.
Thank you. Thank you for introducing me, and thank you to our organization for the opportunity. Hello, everyone. I will present my first results of my master's degree. We performed one case study in the waste pickers of materials recyclable cooperatives in Assis, São Paulo, aiming at identify problems associated with the commercialization of post-consumer plastic packaging waste, PCPP. The methodology adopted was direct observation of waste pickers routine and interviews with waste pickers. The results showed PCPP food was the most difficult for commercialization. So it was divided into groups, difficult to sell and not sold. The examples found in the first group were milk bottles, food oil bottles, and others. And in the second group were flexible packaging, backer packaging, and others. These problems of commercialization are related, among other factors, to flaws Brazil's reverse logistics system. Reverse logistics is an obligation in Brazil, according to national legislation, and the companies comply this obligation through two main models. The first and more common is reverse logistics credits. In this model, companies buy credits from cooperatives. These credits are fiscal receipts of materials sold to recycling industry. That's a good solution, but the problem is, the flaw is, in some cases, companies sell for consumers one type of packaging, one type of plastic, and buy credits from cooperative of another type of plastic. And so the packaging sold by company isn't recycled in this model. And the second model, not so common but used in Brazil, is reverse logistics program to collect specific packaging. That's a good solution too, but the problem is the most programs are in pilot stage and only available only developed regions of Brazil. So it is possible to conclude in both cases a large amount of packaging, of plastic packaging, isn't recycled, and there are flaws in compliance with legislation, mainly by producers who place products difficult to recycle on the market and assume no responsibility for their final destination. So that's it. Thank you for your attention.
Thank you, Anna, for your informative presentation.
Thank you.
Now, ladies and gentlemen, we have come to the last presentation of the poster session. Please be reminded that after this presentation, we will have a brief question and answer session. Let's welcome our last presenter, Riccardo Pauli from Latvia, whose presentation title is Life Cycle Analysis of Food Waste Treatment by Black Soldier Fly, a comparison with conventional treatment options. Riccardo is a PhD student at the Riga Technical University, where he follows projects in the field of life cycle sustainability assessment. Riccardo, please, the floor is yours.
Hello, everyone. Today I will present the research of my master thesis, Life Cycle Assessment of Food Waste Treatment by Black Soldier Fly, a comparison with conventional treatment option. The highlights of the study are analyze the environmental benefit related to the organic waste treatment process by the Black Soldier Fly through a life cycle assessment, and with the novelty of creating a range of results that vary according to how some parameters are chosen, and then make a comparison of the result obtained with the current treatment technique for this kind of waste. My LC study started with a functional unit of 1 ton of food waste per day, with the goal of estimated environmental impact of the BSF treatment, and then make a comparison with the other standard techniques. As method of analysis, I've chosen the Impact 2002 Plus on CIMAPRO software, with a special focus on the underscored midpoint categories that are also the most used in literature. As a life cycle inventory, I've taken data from literature and then readapted to my functional unit. For the first result, the scenario 0 are data of just the simple treatment, and as you can see, the highest impact circled in red are land occupation, global warming, and non-renewable energy. For that, I proceed with the sensitivity analysis on 5 parameters, 2 scenarios, and 2 different methods of characterization. I've chosen these parameters because are that one that can reduce the impact that I've shown you before. The best results obtained from the sensitivity analysis are that one on the use of renewable energy, and also choosing the protein from the larvae obtained at the end of the process as a fish meal substitution, that is also if it fits perfect with the circular economy aims. As you can see, squared in red, there are the results of the sensitivity analysis. With the highest is the scenario 0 results, with the lowest, with the positive environmental impact, is given from the sensitivity analysis. With these results, I made the comparison with the other standard technique, with data taken from literature. I've reported just the global warming here, that is the most interesting one. And as you can see, the BSF treatment is the orange point, circled in red, has similar results to anaerobic digestion and composting, while really lower compared to sanitary landfill. But with the range of values that I created, I'm able to obtain lower impact at all. Thank you for your attention, and I finish.
Thank you very much, Ricardo, for your really extensive presentation and very informative presentation. So thank you very much to all our presenters for their presentations. And now we come to the question and answer session. We will be randomly selecting a few questions from the audience for our presenters to respond to. So our first question is from Hilma Alvarado to Ana Maria. So Ana Maria, did you identify any impacts of the pandemic on selective collection in the sites that you reached?
Yes, thank you, Wilma, for the question. Yes, actually, there was a big impact on the selective collection in the first months of the pandemic last year. And some cities had to stop or reduce the selective collection service. And some waste pickers were left without any income. So this was terrible for them. And we found just few initiatives to provide food and income to the waste pickers. So some governments did this, but not all of them. And some waste pickers were left without nothing. But now the selective collection is back. And of course, there is some consequence, but I think it's better now.
Thank you, Anna, for your answer. Now I have one question to Ashpreet Kaur. So the zero waste plan or policy is becoming more difficult, especially after the China ban for importing waste plastic for recycling. So in this context, in the USA, are there enough facilities for reusing and recycling? So what do you think?
So like recycling plastic specifically?
Yes.
I am not sure about recycling plastic as such, but what I know is that since the ban, the market has gone down, especially in Florida. We don't have, like the university has to pay the local county to like recycle it. They don't get anything back. But in India, I think it's different because in India, if we give the plastic, we get the money back. But in the States, it's like you have to pay for your plastic. So for reusing, I know what Florida is working on, like banning the single-use plastic and using disposable, like compostable straws. So that is something what Florida is working on, especially with the dining. And since COVID, people started taking out a lot of food home. So the government is like putting ban on the styrofoam takeouts and working towards compostable cutlery.
Thank you, Ashpreet, for your answer. Now I have one question from Jaisurya to Laura. So Laura, can you please explain more about the separation process that you used for separating plastics?
Yeah, sure. Thanks. We used just a one-stage process. What we used was a standard industry depackager for separating the light fraction. So that's plastics and textiles and similar material, similar contaminants.
Thank you very much, Laura. So another question, it also came from Jaisurya. So this question is again for Ana Maria. So how about incinerating the mask and medical waste with available incineration facilities in Brazil? So Ana.
Thank you for the question. Yeah, I think it's just one of the different solutions we can select, but we don't have much incineration plants in Brazil. We have just a few. It's not cheap, it's expensive. So we need to study deeply to find the best solution. And Brazil is a big country, so a good solution for one state could not be the best for another. So we need to do more research about this. But I think the most important now is to create collection points and to provide environmental education of the population, because we can see masks everywhere, in the streets, in parks, in rivers, and this is a big problem.
Thank you, Ana, for your elaborative answer. I don't have any other questions right now. So if you have any questions, then feel free to contact with our presenters, and you can also send the questions to me. I can forward the questions to the presenters. So thank you very much to everyone who submitted a question and to all of our brilliant speakers. Now I leave the floor to Dr. Navarro.
Thank you, Aziz. I think that we have 5 minutes more. I would like to give a chance to the speakers to answer to a few questions that I've prepared, if you agree, also because we are in time. And I would like to give place also to the poster session speakers, since 3 minutes, I know that is not very much. So please, I start from the first one. So Davide, welcome here. And I would like to know something more about your technology in terms of economic sustainability, affordability. Did you assess it? Would you like to tell us something more about that?
Yes, we want to try to find a solution for a problem, the protein demand. So we wanted to find an alternative sustainable source of protein. We try to grow Saccharomyces cerevisiae, that is a common yeast that you can find in the supermarket, and you can use normally. But we want to use not a pure substrate like glucose that are expensive substrate. We want to use a waste. So we try to use a wastewater from a confection industry, and we have some good news.
Very good, Davide. Really a good technology.
Thank you.
Really, we go forward the circular economy with all these such information. Thank you very much, Davide, again.
Thank you.
And then we can ask to Ana, please, Ana Paula. Very interesting your study in relation to waste speaker. I think that in Latin America is a great topic that should be assessed. So I would like to know from you in Brazil, are waste speakers accepted by local citizens, policymakers, and so on, in relation also to this informal recycling, informal collection? Are they accepted? How is working there?
Sorry, can you repeat, please?
Of course. I do it shortly. If you can tell us about social inclusion of waste speaker, are they accepted by the citizens?
Sorry, I'm learning English still, so
don't worry. Okay, that's fine. Don't worry. Okay, it's only if you can tell us about waste speakers, social acceptance.
You asking me about open to waste speakers?
Yes.
Openness for work with universe projects.
For example. No. Yes. That's fine.
Yeah, it is a problem before I I don't know if before I initiate my research, I need past time meeting with speakers and I don't know. I need a time. I don't know.
No, that's fine. That's fine, Paula. Thank you very much also for your presentation. Very good. It's because from Brazil, many information from waste speakers are well known in the publication, waste speakers in scientific literature. However, I would like to know something more from you. Thank you very much. Now I can ask to Ricardo, maybe. No, don't worry. We are here for that. And from Ricardo, very interesting life cycle assessment in black soldier fly. So I would like to know from you the main challenges in relation to implement such a life cycle assessment. And I would like also to know from you the future of BSF. Do you think that also your results can support the implementation of such approach for treating organic waste fractions?
Yeah, I think yes, because the main output of my research was mainly looking of some parameters that could be used for a real, maybe also a pilot plant or a bigger plant, because mine were just data from literature. So that can help to choose the best parameters to limit the environmental impact of all the treatment, and that can help the new researches on this field, because it looks really interesting, especially in maybe some developing countries that can't afford a greater plant like an anaerobic digestion or stuff like that. And yes.
Thank you very much, Ricardo.
Yeah.
Very interesting. We hope that also BSF can be another approach, another option, instead of composting, anaerobic digestion, and so on, that can be also supported in developing countries. Last but not the least, Rafael, I would like also to ask from you some hints and tips in relation to cover layers for sanitary landfills, maybe to give to attendees some insights in relation to that. Are cover layers that you studied also be used in other areas similar to Brazil, especially your knowledge, rainy areas or with low temperatures? So which are the main challenges for using this capping layer as technology for treating a sanitary landfill after treatment?
Yeah, I have been studying these layers just to landfills, small landfills or medium landfills in depth sites in a closer process. To apply this technology in another places who receive some materials, we need to study a little more, because, for example, in landfills, it's not only methane and gas carbon that is produced. We need to analyze others like sulfuric gas, and we need to know how these gases interferes in the growth of the community bacteria. I'm just learning about this both because the biggest part of the gases, but to apply in other areas, I don't have this answer to you, because the methanotrophic bacteria are very sensible. So we need to know about a little more about the waste you want to treat. And for dump sites, it's a solution because in Brazil we have still 3,000 areas, and with our new policies about sanitary mark, we need to close the biggest part of them, because it's an inadequate place to put our garbage and our trash. And this can be applied because with the time, the organic matter is start to work as an anaerobic place.
Very good, Rafaela. So you provide us also another field of research, because we have to know something more about that. So finally, thank you very much to all the speakers. Thank you very much, Assis, to moderate this session. You did really well. Very high quality presentations. it will be really a challenge for us to evaluate the best one. So thank you very much again. Now we can have a 5 minutes break. So at 4:50 Central European Summer Time, we can proceed with our special session. Please stay with us, because it will be really, really a nice session that is quite different between other conference that you attendees might be seen during your life. So please join us in the special session and stay with us. Thank you very much. See you in 5 minutes.
I don't know if y'all can hear me, but I can't hear. Oh, yeah, that's okay.
We are having a break now. Thank you.
Oh, okay. Okay, perfect.
Okay, so ladies and gentlemen, here we are at the last session of our conference. Please welcome Dr. Amani Malouf to the stage. Dr. Amani and I are going to moderate the special session. Dr. Amani is postdoctoral researcher in environmental engineering in the UK and co-chair of the Research and Innovation Working Group. Welcome, Amani.
Thank you, Navarro, and welcome everyone. We arrive now to the final session of day 2. This session aims to give voice to marginalized communities and forgotten communities. It is intended to share stories of informal recyclers, workers, threatened people, workers in dump sites, scavengers, female waste pickers, and kids, teenagers who are exploited. So please share us your comments in the question box on your right. This special session is dedicated to highlight priority issues in different regions around the world, while stressing on the socioeconomic factors towards more sustainable cities. We collected ideas for improving solid waste management with non-experts in this field, and would share ideas to improve the production and consumption patterns for more circular cities and societies. Today, we welcome experiences of young journalists, photographers, activists, sociologists, economists, psychologists, philosophers, policy consultants, entrepreneurs who would like to share their stories and experience in this field. So let's start with this inspiring session. I leave the floor to my colleague Navarro to moderate this session. Navarro, the floor is yours. Yeah.
Thank you very much, Amani. So now let's start with the first video from Joseph Huayanca and Álvaro Reyes from Peru. Joseph is founder of Recíclalo, the first association of recyclers of used oil in Peru, and member of ISWA YPG Peru, while Álvaro is Bachelor of Science in Environmental Engineering from the National University of Engineering in Peru. Their video is about an interesting recycling association where used oil is recovered. Let's see how it is.
Por suerte, nuestro planeta es resiliente, pero el mensaje del secretario general de las Naciones Unidas nos dice que la degradación de nuestro mundo natural está socavando el bienestar de 3.200 millones de personas, o lo que es lo mismo decir, el 40% de nuestra población. Por suerte, nuestro planeta es resiliente, pero necesita nuestra ayuda. Mi nombre es Joseph Huayanca, presidente fundador de Recíclalo, que es la primera asociación de recicladores de aceites usados y grasas animales en el Perú. En el Perú se originan aproximadamente 21 toneladas de residuos sólidos al día y solo el 1% se valoriza. Nuestro objetivo es mitigar la contaminación del aire, agua y suelo provenientes de la mala disposición de restaurantes y hogares, ya que solo 1 litro de aceite usado de cocina vertido en el agua contamina 1000 litros de agua, lo que es equivalente al consumo de una persona al año.
Hola, ¿qué tal? Muy buenos días. Mi nombre es Paul Ramírez, soy el jefe de operaciones en Recíclalo. Y bueno, quiero contarles un poco más de nosotros. En el primer plano, nosotros vemos 3 aspectos fundamentales en el tema del reciclaje, por ejemplo, en social, en lo ambiental y en lo económico. En lo social, lo que queremos nosotros en sí es conseguir gente o personas que estén interesados en reciclar aceite, que se especialicen en este sistema de recolección, y nosotros, mediante todo nuestro soporte legal, poder asesorarlos y puedan reciclar e integrarse a esta red de reciclaje. En lo ambiental, nosotros tenemos un impacto directo dentro de la recolección, ya por volúmenes que vamos generando mes a mes. Podemos influir que prácticamente el reto es llegar a las 100 toneladas mensuales, y en base a ello integrar diferentes recicladores para poder darle un valor agregado a ellos, un buen precio por el volumen recolectado y poder así nosotros de esta manera aumentar nuestra recolección. Hablemos del tema del servicio de Recíclalo. Recíclalo garantiza a los restaurantes, hoteles o a toda la industria gastronómica en sí la trazabilidad del residuo, ¿no? O sea, que tengan por seguro que ese residuo es procesado o es almacenado correctamente para luego posteriormente se vuelve materia prima para exportación y elaboración de biocombustible. Garantizamos a nuestros clientes o a toda la red que recicla con nosotros que está garantizado la trazabilidad, ¿no? Desde la fuente, desde la recolección en el primer punto hasta nuestros almacenes que vienen a almacenarse, que pasan por un proceso de filtración y luego son almacenados, ¿no? Y así garantizar también a nuestros proveedores un aceite de alta calidad.
Hola, buenas tardes, mi nombre es Robert Díaz, trabajo en Recíclalo. Mi trabajo acá consiste en filtrar el aceite, recepcionar el aceite que llega de la calle, de las rutas, ver qué calidad tiene el aceite que nosotros recibimos y entonces así podemos determinar si el aceite viene limpio, viene sucio y vemos la calidad de cada tipo de aceite que viene según la zona en la que trabajemos.
Mi experiencia en el reciclaje es que he aprendido muchas cosas sobre el aceite usado, el aceite quemado, como saber cuando el aceite está contaminado con agua, saber cuando el aceite está demasiado quemado, está poco uso, mucho uso, saber cuando el aceite está fuera de contaminación de basura, de comida, de agua. Bueno, mi trabajo de Recíclalo es ir a un punto como pollería, chifas, un restaurante a reciclar el aceite. Llego, me presento como Recíclalo, bajo con un tacho azul limpio desinfectado, cambio el tacho azul que ellos tienen con líquidos infectado con aceite quemado, hago una guía, se la entrego al cliente, ese aceite va a proceso a planta, que es nuestro centro de acopio.
Hola, sí, mi nombre es Denis Bayona, encargado de la zona Piura Tumbes. Lo que he aprendido en este tiempo de Recíclalo es a poder preservar el medio ambiente, reciclando los aceites usados de cocina, ¿no? Que sobre todo contaminan las playas, los mares, colapsan los desagües, se pone duro eso y sobre todo enseñar una cultura de sensibilización ambiental a la población de Talara y Piura, que está a falta de eso, ¿no? Y sobre todo a que colaboren a cuidar el medio ambiente.
Very inspiring, very interesting business. So thank you very much, Joseph. And Alvaro, would you like to add something about this business?
Yes. Hello, everyone. Thank you, Navarro and Amani, for the introduction. So I want to add something and make clear the added value of this type of model business we have implemented. So as well as in most of the countries in Latin America, we still have serious problems related to the informality of recyclers. In our case, especially of the ones that recycle used cooking oils. So one of the main reasons for this high rate of informality is the high cost of formalizing the recyclers itself within our legal framework, and also the variability of the prices of this type of waste. So these waste pickers or recyclers, as we call them here, work in unsanitary conditions, and they develop most of them develop some illnesses because of the working conditions they have. You know, they don't have most of the times they don't have their protective equipment and adequate equipment, and the working days and the physical demand and the long working days make them to damage their own health. So Recíclalo, it's a business that tries to ensure the health of these recyclers and also to improve their quality of life. So all recyclers in this type of business have adequate personal equipment, and they ensure their safety conditions during work. Besides, they are well trained for these activities. Also, Reciclalo is not just a recycling model business, but it also collaborates with some research studies. It makes agreements with different organizations and universities in Peru. In fact, it has a project named Biofuel Briquettes, which is basically, it is being developed, but it is basically briquettes made of residues of used oil and other type of waste. And this type of biofuel or recovered fuel will replace the firewood used in community kitchens and make like and help this type of people in these community kitchens. Reciclaro also has a food exchange program with some villages from different states in Peru, and these agreements allows that the waste of these used oils can be sold in different markets, and the income that is received for this selling can be used to buy food to children, uniforms, and different toiletries to help improve quality of life of these communities. So as a result, I need to conclude and make clear that Reciclalo is not just a business model, but it also generates social value to our work. And therefore, we can become essential service providers. So that's what I wanted to add.
Thank you very much, Alvaro. So environmental, social, economic support toward the circular economy. Great experience. Thank you very much to join us today. Thank you.
Okay, thanks.
Thank you. Okay, if we do not want to add something more here, we can proceed with the second video and the second presenter. So let's welcome Jan Vohanginirina from Madagascar. Jan is CEO of Build for Impact, based in Madagascar, actively working for a better waste management, mostly concerning plastics. The video that we are going to see show as a very interesting business for the recovery of waste and raw materials in Madagascar. So now let's see how is working the second great business.
Bonjour, je m'appelle Yann Vanginirina, j'ai créé Build for Impact en novembre 2020 et mon entreprise agit dans le recyclage, principalement de plastique. Aujourd'hui, à la décharge d'un challenge, plus de 500 tonnes par jour sont déposées. Ils ne représentent que 30 à 40% des déchets récupérés dans la vie. 500 tonnes par jour, cela représente 15 000 tonnes par mois. À ce rythme-là, les 5 prochaines années seront déterminantes pour la gestion des déchets du pays. BFI propose d'agir dès maintenant. Nous recyclons fûts, palettes et bien sûr plastique, principalement les bouteilles. 10 000 bouteilles par mois, c'est le nombre de bouteilles que nous transformons aujourd'hui. C'est un chiffre encourageant mais qui paraît dérisoire. Les besoins sont bien plus importants. C'est pourquoi BFI souhaite étendre son champ d'action et développer de multiples projets afin d'impacter efficacement la gestion des déchets. Nous souhaitons également apporter un impact social. BFI travaille déjà avec différentes communes de Tananarive. La main-d'œuvre des différents projets sera locale. Nous encourageons la communauté à travailler pour la communauté. Ainsi, nous couplons la récupération des déchets à une redistribution des revenus. Nos idées sont nombreuses et viables. Nous invitons donc toute personne, entreprise, commune à nous rejoindre dans ce projet d'avenir et agir aujourd'hui pour un futur propre en phase avec les besoins du pays.
Great experiences and amazing solution. Thank you very much, Jan, for sharing with us your video and your experience. Please, would you like to add something more about your green business? Your microphone, Jan, please. Turn off the video. You can enable also your microphone, please. enabling the microphone, there is a button near the same one of the video. So I'm sure that you are looking for that. Meanwhile, congratulations for your amazing business. Very circular, very interesting. I'm sure that in Madagascar is very useful, something like that. Also because you told us that many tons of plastic are disposed of in final disposal sites. You cannot do it. We can try again. Yes, okay, let's move to the next. So for solving these issues that can happen, we can proceed with Biswajit Debnath. We have another presentation, the third. Biswajit from India is Commonwealth Split Site Scholar at Ashton. Oh, so Jan, okay, yeah. Can you join us? Perfect.
Yeah, I'm sorry.
No, perfect. Please, if you can tell us something more about your business in Madagascar.
I'm sorry, Bija. If I can take like 5 minutes to talk.
Yes, please. The floor is yours.
Okay. So I wanted to talk about 3 main ideas beside the gas release problem. There are 3 main problems I can see in Tananarive, the capital of Madagascar. The first is visual and olfactive issues. All around the street in Antananarivo, you can see overpacked, overload garbage bins. In the smallest and the least frequented part of the capital, plastic waste are piling up on the roadside. The others is also degrading the environment of thousands of people. And personally, I say to myself sometimes that the saddest part of this is that the Malagasy people are used to it. And that's sad. The second issue is the soil quality and the irrigation issues. During the 5 months span, we got the raining season. It's a big problem because for the irrigation topic, there's almost like tons of plastic in the road that is how can I say that is ending up stuff inside the public pipes and patching sewers. So the waters can flow out the streets, causing torrents of water that can be dangerous, and causing devastating floods. They also end up in rice fields, which is the main food income in Madagascar. So the degradation also can be impregnated deeply in the ground, reaching the water table, which will be a problem for several years. And the third and last, it's a little bit more, personal. It's the psychological impact on the Malagasy citizen. Obviously, anybody knows that in developing countries, the social levels are closely coexisting. The wealthiest people almost doesn't see no more the impoverished one, but them, they do, which means that they know that they are living in a way that can legitimately be seen as a non-deserved living standards. Some say that they're the only problems. They are the one who doesn't put their trashes in the bin, but the bin is fully packed. So there's the ones who say that there does their vital businesses in the street, but there's not enough public bathroom. So I can go like that for a long time, but on top of that, I always say that everybody needs to do something at their stage. However, you got to try to project yourself in the people's vision. And I will not give all my time and energy to recycle my trash if I don't even know what I'm going to eat today, what I'm going to give to my child. So we gotta understand the dominant social class perspective. They may be impactful on the pollution, but they are also the most affected by the whole country's pollution. We got to work together, join force, and give each other tools to fight these waste management problems and issues. That's all.
Thank you very much, Ian. Thank you for your words, very inspiring also. And thank you for sharing with us your experience and your case study in Madagascar, which is also another country where also efforts should be spent for solving the issue related to solid waste management. Thank you very much, Ian, again, for joining us.
Thank you. Thank you all.
And finally, we have a third presentation, a third video from India. Now, yes, so we can introduce Vishwajit Devnath. So please welcome on stage. Vishwajit is a Commonwealth Split Site Scholar at Ashton University in UK and Senior Research Fellow at Jadavpur University in India. The video that we are going to see shows us a detailed description of the approach followed to involve green warriors. Let's see how Indian green heroes are.
Good afternoon, myself Vishwajit Devnath, and I'm going to present on Vocal for Local Unsung Green Warriors, an enabler of circular economy. This is the roadmap of my presentation. Now, it all starts with the solid waste management issue in India. So it generates nearly 52 million tons of waste each year, out of which 70% is collected and about 12 million tons are only treated, and the rest is dumped in the landfill sites. And the informal sector is basically associated with dealing with the 90% of this whole treatment process. Now, the limitation of knowledge and awareness about waste management is there among the common civilians, and there are also several misconceptions among people. So it is important to make people aware, and the awareness should be at the correct. Now if we come to the Indian culture, now the reusing of things, this culture is there in India since forever. We often reuse things. We buy a jar of honey, it's finished, we wash it and we put some spices in it or store something else. Now there are several works being carried out in personal level, in micro industrial level, but the work is tremendous. It's the upcycling is just a new name. Now back in 90s, my grandmother used to make different stuff out of plastics. So today we are doing it and calling it upcycling, but back in 1990s when I was just a kid, I saw it happening. So it's there in the culture, and what happens is the mainstream media fails to capture these small achievements, and ultimately the overall process slows down, because when you don't appreciate someone, basically the whole process slows down. So it is important to acknowledge and appreciate such initiatives and approaches which are occurring at very personal level, at a very grassroots level. So when you acknowledge these people, when you acknowledge their work, they can inspire people to do more. It can generate more awareness. It will educate a larger mass in turn, so others can get inspired as well. So from there, our basic objective is to appreciate and acknowledge these local green warriors who are doing their bit, their appreciative initiatives at personal and grassroots levels, and to provide a platform to tell their stories, the stories of the local green warriors. So basically, who are we? We are just four rookies trying to do something good. So myself, Bishwajit, and then we have Ankita Dash, who is a very good researcher. So she is the co-founder of CRSD. So what is CRSD will come in a minute. Tirthankar Mukherjee and Shweta Mitra, again, two tremendously active active researchers, and they are executive members of CRSD. So what is CRSD? CRSD is basically a consortium of researchers for sustainable development. So we are a group of researchers. So basically we started back in 2017 with 7 members, and then we had the name called Consortium of Researchers for Environmental Protection, Sustainability and Climate Change. But later on we changed our name to CRSD, and we are operating under the aegis of Siddhivinayak Private Limited since December 2019. So that is CRSD for you. You can see the our working WhatsApp group I have put some screenshots here. So now we are 27 members who are dedicated to doing research on sustainability. So we are working in our different aspects of sustainability. Someone is from chemical background, someone is from environmental, someone is from computer science. So they are doing all their bit. Now growing up, we understood that only research inputs and research outputs will not get the job done. So we wanted to do something on the ground. So as a very small initiative, as a very small beginning, we just started a plastic waste management group in WhatsApp. We started on June 2021 with just 15 members, and now it has grown to 51 members, and there's very good response among the members, and they are making baby steps towards sustainability, their very own steps. As you can see, I have also shown the screenshot of our WhatsApp group that we are working on, and this and here all the members are interacting with each other. Everybody has their own achievements to share. Somebody is happy with the new coffee mug, somebody is happy with their new plant, somebody is using bamboo toothbrush. So they are actually sharing with each other, they're interacting with each other, and all the times the group admins doesn't need to get involved. So and everything is happening in a local level, in the local language. So these are our local heroes, these people are the local heroes, these are the green warriors. So gearing up with we want to give these local heroes a platform so that we can share their stories. So we have planned a newsletter, it's called Wastage. It will be, there will be 4 issues per year. It will be only in digital versions of this. So we are planning the inaugural issue on 2nd of October 2021, which is the birthday of Mahatma Gandhi. So Mahatma Gandhi is sort of the forefather, at least the philosophical and theoretical forefather of the proper solid waste management in India. So which also inspired the Swachh Bharat mission maybe 5-6 years back that was started. So that's the reason we are planning it on 2nd of October, and we also are getting some good support from our industry collaborators. So here are the snapshots of our green warriors. So as you can see, I have posted some snapshots from our WhatsApp group. So some people is very happy reusing their jar and using it for growing a plant. Someone is happy with their sustainable packaging or paper bags, and then someone is happy to showcase their new achievement of using a copper bottle. So let us now hear what our green warriors have to say.
Hi, I am Dr. Shashwati Kharami and I am trying to be a green warrior. So I am doing my part in betterment of this environment, to make a better environment, to make a better world. So in doing so, I have bought this biodegradable bamboo toothbrush from Amazon and been using this for this past month, and I am feeling great in using these products. So I have decided to also minimize my plastic usage gradually, and also have been planning to make take such mini steps towards sustainability in this near coming future, because it is necessary for us and for our environment.
Hello everyone, I am Choyan Acharya and I am trying to be a green warrior. Recently I have eliminated plastic from my day-to-day life. I usually carry jute and canvas bags for marketing and daily practices. I hope you will do the same for a better green earth tomorrow. Thank you.
Hi, I'm Tathagata Mukherjee and I'm trying to be a green warrior, and in doing so I have bought these paper cups, and I am strongly encouraging, and it have made my motive to encourage people so that they start using these paper cups or any other paper straws, paper spoons, whatever it is biodegradable, so that the environment is like a much safer place for us. Thank you.
So as you can see, the awareness level is different for different people. So going ahead, we are planning to start an organization for that purpose and for some bigger purpose as well. So for that, the core committee is formed now. The resolutions are now under preparation, and we are looking forward to register by January 2022. Yes, it's true, due to COVID-19 and other things going on, we are a little bit on the back foot, but yes, we are optimistic that we'll be able to do it by January 2022. So ISWA YPG, thank you ISWA YPG for allowing us to showcase what we are trying to do here. Siddhivina for backing us up, and Professor Amar Chandra Das for his inputs and insights in our journey. These are our collaborators. Thank you.
So thank you very much, Bishwajit, for joining us, for sharing with us your presentation. And would you like to add something more about these Green Warriors? I would like to be one of them too.
Sure. You can be one of the Green Warriors, and each and every citizen of this world can be a Green Warrior. So basically, my I would like to share my views. So when I grew up, I used to did a lot of very small things, and I was never getting appreciated from whoever it was. So I was always in a negligent position. So that inspired me. Whenever I see something good happening, I inspire each and every little bit of it. Even I was in a sweet shop just 2-3 days back. So they have started using a biodegradable plastics instead of the usual plastic. So I have congratulated them. I spoke to the owner of the shop, and I told that person that, okay, this is a very good thing. Please continue doing it. So whenever I see something good things happening, I try to appreciate that, so that appreciative nature can become contagious, and it can help a lot more people. So that's my approach. It might be a little bit out of the book, a little bit out of the box, but that's how I do it. And that's the very basic motto of what we are trying to do through this WhatsApp group and what we are planning for the future. And I have a very small message for the the audience, a very small takeaway message. So I would like to say that when you do something, when you want to appreciate something, when you know you are doing something good, convince 5 more people to do that, and tell them to convince 5 more people, so that the wave never stops. So that's my idea, that's my message. And I think in due course of time, we will be able to spread this thing in a bigger way, because already you have seen in the message, these people are very happy with their small achievements. And then there are some small SHGs, we call them, self-help groups. They work together and they develop something beautiful out of that. So we have a plan to train those people to do things in a sustainable way, in a green way, to the least, if it's not sustainable in terms of the indexes and the numbers, but at least they are green in green approach, whatever they're trying to do. So that's our plan, and that's how we want to move forward. And we believe that in the near future, we will be able to move towards something better than where we are today. So, it's a never-ending process of continual improvement. So I'm optimistic for it. That's all.
Thank you very much for your contribution, Bishwajit. So, Amani, would you like to add some comments to this session?
Thank you, Navarro, and thank you all for sharing with us your innovative projects and for trying to spread awareness and helping your communities in Peru, Madagascar, and India. You have full support from the ISWA Young Professionals Group, who are here to support you. Now, let's conclude with the last video prepared by ISWA that is going to show us the challenges that we are going to face toward 2030, the envisioned decade of changes toward the circular economy era. I would like to end this session by an urgent call for drastic changes in our societies, because it's not only about waste, but also about people. We call for changes in corporate governance that do not only affect our economies, but also our lives, and whoever overexploited our public resources and created irreversible damages that threaten people's life and all kinds of species. It's time to invest in involving young professionals and young responsible leaders to make changes in our societies instead of shutting them down and giving them no choice but to abandon their home countries. Join us with ISWA and be part of the change. Now I leave the floor again to my colleague Navarro for closing the online conference. Thank you.
Thank you, Amani. Thank you to all the speakers. And we are now arriving at the end of the first ISWA YPG online conference. Organizing this conference by itself presents an innovation in cooperation with more than 10 committee members and more than 15 members of the scientific committee, based in about 15 countries and working in different time zones. Amazing. We delivered our best efforts to create an enriching experience to you all. Everyone played an important role in making this conference happen. We feel very lucky to have worked closely with you all. Thank you so much to everyone. Finally, I remind the attendees to do not forget to join us at the ISWA YPG and the Research and Innovation Working Group, where I and Amani are co-leaders. Join us and be part of the change. We need more green warriors, circular businesses, and green production activities to move towards a sustainable future. Please remember that also the 1st of October will be the World Congress of ISWA with special fees for young professionals. In addition, you can keep updated on our website, where you are going to find the records of the conference book, and the announcement of the 3 best presenters of our competition. So stay tuned. The winners will be announced in the next few days. Let me say that all presentations were really of high level, and it will be really difficult to award and to assign the awards. Finally, I take advantage of this international platform to say that we need more environmental leaders, as we saw today. And with that, ladies and gentlemen, we come to the end of the first ISWA YPG Online Conference, the path towards 2030, the vision decade of changes toward the circular economy era. Are you, a young professional, ready for this challenge? Amani, do you like to add something to conclude this event, please? The floor is yours.
Thank you, Navarro. It was an intensive and interesting 2 days conference, with many insightful messages sent to us by the speakers. We can say that the circular economy era can become a reality thanks to these young circular thinkers. We are so thankful to the ISWA Secretariat and ISWA event manager for supporting the ISWA YPG in every step of the organization of this conference. Special thanks extend to the honorary speakers, Mr. Carlos Silva Fijo, Dr. Anne Ragosning, and Professor Sahadat Hussein for accepting our invitation and for presenting themselves as inspiration models for the future of waste management. I would like to extend my gratitude to all scientific committee members and organizing committee members. Thank you, Dan and Ronald, for your continuous support. Thank you, Chantal, for the tons of emails you've been sending. Thank you, Siddhartha, for coordinating all the abstracts we have been receiving. Thanks, Rachel, for marketing this event. Thanks, Ankur, for creating this design and for all your creativity in the conference material. Thanks, Aditi, for coordinating the panel session. Thanks, Leonie, for your patience and managing this platform. Thanks, Barbara and Soraya, for managing the conference book. And finally, many thanks to Asfarit, Aziz, Hani, and Maria for coordinating and moderating the sessions. And of course, big thank you to my colleague Navarro. Without you, this event wouldn't have happened. Thank you also for the former research team and leadership team of the YPG for having this idea to initiate this series of annual conferences and for building up success every year. On behalf of all the organizers and committee members, I would like to express my utmost gratitude to all our wonderful speakers, presenters, and YPG members for making this event a success. And of course, a huge thank you to our audience who have joined us from all over the world. We hope you have enjoyed the conference, found it informative and inspiring, and thank you very much for joining us. And I hope to see you next year at the 5th ISWA YPG online conference. Thank you all.
Thank you very much. So it's the end. Thank you all and see you. And thank you very much, Amani, for all the support and for co-organizing this conference. Very, very inspiring everything. Thank you for your support.
Thanks you also, Navarro.
Okay.
See you next
all.
year.
Bye. Thank you.